Hello everybody, welcome back. Now we are going to start Hibernate. So before studying Hibernate, we need to know some concepts. And in order to make the data produced by a Java application permanent by a Java programmer, we have the following options or approaches. What is the first approach? That is approach one is a Java programmer can make use of IO streams to store the data in a flat file, and we can read the data from the flat file whenever it is required. So when used in that is Java programmer will make use of IO streams to store the data in a flat file, and we can read the data from the flat file whenever it is required. And approach one is the use of a file. We are making use of a file to read the data. And approach two is while developing in real-time applications, the data in Java applications will be in the form of objects. So in order to store objects or read objects using the backend as a file, we have serialization and deserialization mechanism. In serialization, we store a Java object into a flat file, and deserialization will read an object from a file. So what are the drawbacks of files? Files are complex to work with them because file does not have any query language support. And second drawback is files are not secure. And third drawback is files does not support relationship between data and JDBC in a Java relationship between data and JDBC in a Java standard edition. And approach three is because of the drawbacks of file management system, we entered into database management system. JDBC is a technology given by Sun Microsystems under Java Standard Edition module, and it is used to communicate with from Java application to database. So JDBC transfers data to and fro in the form of text. JDBC is a technology introduced after ODBC. Now, what are the drawbacks of JDBC? JDBC uses SQL commands directly. So, JDBC persistency logic is database dependent. In JDBC, a programmer must explicitly close the connection. Otherwise, at a later point of time, there is a chance of getting out of connections error. And JDBC does not support inheritance and OOPS principles like inheritance and polymorphism. JDBC does not support collections, relationships, and associations like one to many, many to one, etc. And JDBC API is a database independent JDBC logic, whereas JDBC logic is a database dependent. And JDBC process is very slow, very less, or very slow. And JDBC technology is a JSC module, and in JDBC, all the exceptions belong to checked exceptions. So it is forcing the programmer to write the try and catch blocks, or the programmer should write the throws exceptions. It means increase in the burden of the programmer. So after JDBC application development is completed, if the structure at the database side is modified, then the entire JDBC application needs to be modified. It means debugging process of a JDBC application is a time consuming process. So approach 4 is the entity beans. Using of entity beans, that is in order to overcome the problem of JDBC technology, Sun Microsystems given other persistent technology at the Java EE module called as entity beans. Now entity beans are server-side components and provides persistence operations for the Java application. Entity beans are going to transfer object format of data between Java application and the database. And what are the drawbacks of entity beans? Entity beans are called heavyweight components because an entity bean has large set of life cycle, and entity beans is only working with server side. So we must install a server in the system to work with entity beans. And while working with entity beans, if any problem is occurred, then we need to shut down the server, modify and reload the server. Thus, we need to restart the server and then we need to test our application. Then it is a complex and time consuming process. And construction of entity beans required multiple Java files and multiple XML files. It increases the burden on the programmer. Next approach, approach 5, is in order to overcome the drawbacks of JDBC technology and entity beans technology, vendors introduced ORM tools, that is object relational mapping. ORM tools are bridge between the front end and the back end applications. ORM tools will uh, will fill up the gap between the object model and relational model and transfer the data to and fro in the form of objects. And ORM tools provide persistence operation in the form of objects and provides the database independent persistence logic. And ORM tools uses mapping in order to transfer the data in the form of objects. So and these ORM tools are used to transfer the data between an object model and a relational model in the form of objects. And an object has three elements, that is identity, state, and behavior. While transferring the data in the form of objects into the database, only the state of an object needs to be stored, but not its identity and its behavior. In ORM tools, so ORM tools will get this information through a technique called mapping. All the ORM tools need mapping in order to transfer the data in the form of objects. Now, what is mapping? Mapping is a mechanism of associating the Java class name with the table name and properties, that is the variables of Java class with the columns of the table. And for ORM tools, mapping can be provided in two ways, that is XML by constructing a mapping XML document, and second method is annotations, that is by constructing mapping in the form of annotations. Now, what is Hibernate? Hibernate is an open source and lightweight ORM tool used to transfer the data between Java application and the database in the form of objects. Hibernate is also called as a framework, and we call ORM tools as ORM framework also. Hibernate is an open source tool or framework because of the following. Hibernate software is freely available into the internet. Hibernate can be added new features to by anybody. And the source code of the predefined classes or interfaces, that is Hibernate API, is visible to the public. And Hibernate is a lightweight framework which makes Pojo classes to transfer the data in the form of objects. And Hibernate is a non-invasive or non-intrusive framework. Non-invasive framework means the framework does not force a programmer to extend or implement the classes from any predefined class or an interface given by the framework. We have two types of frameworks, invasive framework and non-invasive framework. Structs framework is an invasive framework. It means the programmer forces to extend the class from predefined class given by the structs framework. Hibernate and Spring are non-invasive frameworks because both the frameworks are going to use Pojo, that is plain old Java objects. And Hibernate is used for implementing persistence logic for Java applications, um, while which are running or which are going to run in a non-server environment. Like JDBC technology, Hibernate is also suitable for all types of Java applications, that is for console applications, web applications, distributed applications, etc. And Hibernate is a Java-based middleware between a Java application and the database and transfers to and fro the data in the form of objects. Hibernate is used as DAO, that is data access object, in real-time applications. And Hibernate is an abstraction layer on the top of the existing JDBC technology. It means Hibernate internally uses JDBC API for providing the persistency operation in the form of objects. And what are the features of Hibernate or the advantages of Hibernate? Okay, then, so this is about Hibernate. So, Hibernate, this is about the Hibernate introduction. Okay, I'll continue in the next class. Hope you understood. Okay, thank you. Hello, hello everybody. Now we'll see the advantages of Hibernate. Now we'll see what are the features of Hibernate. As I said, Hibernate is an open source, lightweight ORM object relational mapping tool. And in Hibernate, all the exceptions belong to unchecked exceptions. So a programmer no need to implement the code within the try and catch blocks and no need to put throws exceptions for a method. This is one of the feature of Hibernate. What is the second feature? In Hibernate, there is an inbuilt exception translator, and this translator converts the checked exceptions of JDBC into unchecked exceptions of Hibernate. So all the exceptions in Hibernate belong to unchecked exceptions type. This is the second update. And this is the second feature. And the third feature is Hibernate has provided its own query language called HQL, Hibernate Query Language. By writing it, we can implement database independent persistence logic. An object-oriented form of SQL is called the HQL, Hibernate Query Language. And the next feature is in Hibernate we have lazy loading mechanism, which means Hibernate will wait by loading the objects from the database. And when the object is used in the Java application, then the moment the object is loaded from the database is known as lazy loading, and the performance of applications will be increased. And the next feature is Hibernate automatically generates the tables and the database instead of uh, instead of created by manually by the programmers. We can feature as automatically generation of the database such as the table. And next feature is Hibernate has a benefit of generating primary key value for automatically. And Hibernate supports versioning and timestamps of objects, and Hibernate will store information into the database. Next feature is Hibernate supports caching mechanism. It means whenever we are loading an object from the database, then it will be stored in each memory, and for the next time if the same object is required, then it will be loaded from the cache memory rather than from the database again. It means caching mechanism reduces the number of round trips between a Java application and a database. And in Hibernate, we have two levels of caching: the first level or session level or local level cache, second level session factory level or the global cache. And Hibernate supports OOPS principles like inheritance and polymorphism. Hibernate also supports associations, that is relationships and collections. Hibernate supports the following four types of relations, that is one to many to one, many to many, and one to one. And Hibernate supports the following three types of collections: list, set, and map. So these are the features of Hibernate. Hope you understood. Continue in the next class. Thank you. Hello everybody, welcome back. Now I'll explain about the first Hibernate example and what are the different files required to work with Hibernate. Different files required to work with Hibernate are Pojo class, that is plain old Java object mapping file, configuration file, and the client application. What is a Pojo class? If a Java class is not extending any predefined base class or not implementing any predefined interface given by the API, then we call such type of file as an ordinary Java class of Pojo. A Java bean and Pojo are not the same. In order to say Java class a Java bean, then it has to follow the below rules. Class must be stored in a package. Class must be public. Class implements serializable interface. And properties of the class, that is variables, should be private. and the class must contain public default constructor, and for each variable or property a public setter and a getter are required. And in the if the above rules, even though a Java class is not following some rules, still we are calling that class as a Java bean. In Hibernate, we need Pojo classes but not Java beans. In a Pojo class also, we use setter and getters and default constructors. Now, second one is the mapping file. It is an XML file which contains associations between Pojo class name to table name and Pojo class variables name to the table column names. A mapping file is identified with a file name dot a file name dot sorry a mapping file is identified with mapping file name dot hbm dot xml. A mapping file is an XML file, so its extension is .xml, and Hibernate has added a standard to identify the mapping file easily by providing the extension of .hpm.xml. And extension .hpm is optional, but it is recommended for a mapping file named by Hibernate. For example, student.hpm.xml can also be named as student.xml, but Hibernate recommended to use .hpm for easy identification of the mapping file. In the following mapping files, while constructing the Hibernate mapping XML file, ID represents the primary key mapping and property element represents the non-primary key mapping. In Hibernate mapping file, ID element is mandatory and it must be returned before the property elements. And even though a table does not contain a primary key, but in the mapping file, we must map any one column of the table as ID. And in Hibernate mapping file, ID element is allowed for once, but property element can be repeated any number of times. If a table has more than one primary key, then we call it as a composite key. In this case, we should add composite ID in the place of ID element in the mapping file. And while writing the mapping file, if Pojo class variable name and table column name both are matching, then column attribute is optional in the ID or property element. In the mapping file, variable name, okay, this is about the mapping file. And next is the configuration file. In Hibernate, Hibernate needs some additional properties along with the mapping in order to transfer the objects between Java application and database. The external properties required to the Hibernate will be given to the Hibernate by constructing a configuration file. In a configuration file, we need to add the following three types of properties or information: connection properties, Hibernate properties, and mapping resources. By using connection properties, Hibernate will establish a connection with the database internally. Hibernate properties are used to add some additional information to the Hibernate. Mapping resources is to configure the name and location of mapping files. In Hibernate, mapping files and configuration files are not supported or loaded. When configuration file is loaded, the mapping files are also loaded automatically. In order to load the mapping files also, along with the configuration file, we need to configure the name, location of the mapping file into the configuration file. A configuration file is identified with configuration file name.cfg.xml. The extension .cfg is a Hibernate standard and it is optional, but it is recommended to use the extensions as .cfg.xml in order to identify a configuration file easily. Up to Hibernate 2.x version, the configuration is provided in Hibernate in the form of properties file or resource bundle. From Hibernate 3.x, we are using XML file rather than properties file to provide Hibernate configuration. So this is about the configuration file. And while constructing Hibernate applications, we create one configuration file for each database. It means if we want to communicate with three databases simultaneously or concurrently, then we need to construct three Hibernate configuration files. Hibernate configuration files is said to be the heart of the Hibernate application. And while constructing Hibernate mapping files, we can create number of mapping files in a Hibernate application. It means either we can create an individual mapping file for each Pojo class, or we can create a common mapping file for all Pojo classes. Hibernate configuration file and mapping files. If any changes are done in the XML or XML files, that is Hibernate configuration and mapping files are the XML files, and if any changes are done in these XML files, then we no need to recompile the Java code. We can execute the Java code without making any changes. And while working with the framework software, all the framework software follow some common principles. One of the common principles is framework contains a central configuration file, and when framework application starts in a high level object of the framework, and that high level object is responsive to produce the low level object required in order to work with the framework application. Now we'll see what are the steps required for the client application. Step 1 is to import the Hibernate API into the Java client application. And we have multiple packages which contains a set of classes and interfaces to develop a client application using Hibernate. The following two packages are called base packages of Hibernate API, and we need to import these two packages in each client application of Hibernate. Import org.hibernate.star and import org.hibernate.cfg.star. Then step 2 is to create an object of configuration class. Configuration is a class given in org.hibernate.cfg package. By creating configuration class object, we have bootstrapping the Hibernate environment into a Java application. That is configuration conf object configuration object conf equal to new configuration. And step 3, call configure method of configuration class for loading Hibernate configuration file. While calling configure method, we need to pass the configuration XML file name as parameter. And if the configuration XML file name is hibernate.cfg.xml, then the file name is optional to pass as a parameter. If we use Hibernate configuration file name as other than hibernate.cfg.xml, then it is mandatory to pass XML file name as a parameter in configuration. The syntax is conf.configure of hibernate.cfg.xml. Then configure method is called Hibernate internally uses DOM and SACS. DOM stands for Document Object Model and SACS stands for Simple API for XML parsers, and reads both the configuration and mapping data for XML files and stores the data into the instance variables of the class. Whenever Hibernate configuration file loaded, then automatically the mapping files are loaded, and we do not require to load the mapping files separately. And step 4 is to create a high-level object of Hibernate called Session Factory. Session Factory is an interface given in org.hibernate package, and its implementation class is Session Factory. Implementation class is given by Hibernate Framework, and it is available in org.hibernate.impl package. So to get session factory, we need to call build session factory method of configuration class. That is, syntax is session factory equal to conf.build session factory. The next step is the step 5 is to create or get a session object. Session factory produces sessions, and session is runtime interface between Java application and Hibernate framework. All methods perform operations on database to perform operations on the database are provided by the session object. Session is an interface, and session implementation is implement session implementation is implemented class. Session interface is given in org.hibernate package, and session impl is an implemented class given in org.hibernate.impl package. And the syntax is session object, session equal to factory.open_session. And one session factory can produce any number of sessions. Then step 6 is begin or open a logical transaction while performing save, update, delete operations. from a Java application to database. In Hibernate, we need a logical transaction. If we are reading or loading objects from the database, we do not require any logical transaction in Hibernate because select operation does not belong to transaction operation. In order to get a transaction of Hibernate, we need to call begin transaction given by session interface. So the syntax is transaction tx equal to session dot begin transaction. Then step 7 is to perform the operations on the database by using the methods and objects produced by session interface. That is syntax is session dot save of object or session dot update of object or session dot delete of object. Then step 8 is commit the logical transaction after the compilation of operations. While executing the operations again the database, if any exception is caused, occurred or error is occurred, then Hibernate automatically will roll back the transaction and Hibernate execution will be thrown back to the Java application. The syntax is tx.commit method. And step 9 is after compilation of a transaction, we need to, after completion of the transaction, we need to close the session produced by a session factory. After closing all the sessions produced by session factory, we need to close the session factory of Hibernate. And syntax is session.close and factory.close method. And here all the frameworks belongs to Java EE Enterprise module. All Java EE softwares are non-installable softwares and we will get the software in the form of set of jar files. And working with the framework software is nothing but adding the set of jar files into the class part before executing the framework applications. In all the frameworks, we have the main jar file and dependent jar files. The main jar file contains the API used in the Java application and dependent jar file contains the API used in the classes and metaphrases. While compiling the Java application, the main jar file is required to set in the class path, and while executing, we need both main and dependent jar files into the class path. When we download Hibernate software, then we will get a zip file, and after that, we need to unzip the zip file. The main jar file Hibernate is hibernate3.jar and it exists in the root folder of the software, and the dependent jar file exists in the lib folder. So this is about the first example of the Hibernate. And so I will show you how to run a first Hibernate application. How to run a first Hibernate application. First create a Java application. Go to file, new, and then create a Java project first. For first Hibernate application, go to file, new and create a Java project. Then give the name for the Java project as first Hibernate. Then inside the source, create one package com.hibernate. And inside the package, create two classes. One is employee.java, which is a Pojo class. It contains the properties, integer ID, string first name and last name, and the setters and the getter methods. This is the Pojo class employee.java. And the next one is store data.java. And these two files, employee.java and store data, and this is the client application file. Store data.java is the client application. It should be created in this package. These two files should be created in this package, whereas the configuration files, these XML files should be created in the source. That is, right click on the source. That is, you need to right click on the source, new, and go to other and create an XML file which is located in the XML folder. Then say next and give the file name and say finish. That's how you create these employee.hvm.xml and hibernate.cfg.xml. Both are XML files. So now what this contains, employee.hvm.xml is a mapping file and it contains the class name as com.hibernate.employee. It is the package name followed by class name. and the table is EMP1000. First, what you need to do, go to the MySQL database and create one table EMP1000 with ID integer 11 primary key auto increment, first name varchar of 25, last name varchar of 25. You need to create the table for this EMP1000. Then come back to Eclipse, and inside the class you have an ID attribute, ID name equal ID attribute, ID name equal to ID, and generator class equal to assigned. Next, property name equal to first name, and another property is last name. This is the mapping file. And next one is the, excuse me, here I am getting an error, so I need to comment this detail. And next one is the Hibernate configuration file. The next one is the Hibernate configuration file. So the next one is the Hibernate configuration file. Inside this Hibernate configuration file, I'm having session factory, and property name is hbm2ddl.auto, which value of this is update, and the property name, next property name is dialect, and the dialect for MySQL is org.hibernate.dialect.mysql dialect, and the next property name is connection.url, where you need to give the URL of MySQL, that is jdbc colon mysql colon / localhost colon 3306 / hibernate is the database name. The next property is the connection.username. Username is the loop code here. And property name, next property name is connection.password, where password is loop code. Next property name is connection.driver underscore class, where this is the driver of the MySQL, com.mysql.cj.jdbc.driver. And the mapping resource, we need to provide the mapping file name here, employee.hbm.xml, and end the session factory. Then go to the client application store data.java. Starts with public static void main string args, and configuration conf equal to new configuration. Conf.configure, you need to provide the configuration file in this method, hibernate.cfg.xml. Then produce an object for session factory interface. Session factory equal to conf.build session factory. Then produce an object for session equal to factory.open session. Then transaction t equal to session.begin transaction. Then create an object for employee even equal to new employee. Then set the values for ID. Set the value for ID and first name and last name, and store into the employee object. Then session.save even. Then store this object, employee object, in the session. Then t.commit. You commit the transaction. Then system.out.println successfully saved. Then close the factory and the session. Now when you run on this client application, click on the client application and say run as, and run this Java application. You don't require any server for this. You don't require any server for this Hibernate. Just you need to run on the. Just you need to run as a Java application only. So I'll do one thing. I'll stop here. I'll set the ID as 2. I'll give another set of values. I will give here. Set the ID as 2 and name as James. Now run this application again. This Java application. Okay, then it is output is printed successfully saved. Now you go to the database and check whether the values or records are stored or not. Whether the records are inserted into this table EMP1000. Then you can see here. Second ID is James and Johnny. First name is James and last name is Johnny, which we have given. So this is how you will run the first Hibernate application. Hope you understood, and I'll stop here and continue in the next video. Thank you. Hello everybody, welcome back. In this class I am going to explain that there are two ways of creating the Hibernate applications. One is using XML and the second one is using annotations. First we'll see the Hibernate example using XML in Eclipse. First you need to create the Java project, then add the jar files for the Hibernate, then create the Pojo class or the persistence class, create the mapping file for the persistent class, then create the configuration file, create the class that retrieves or stores the persistent object, then run the application. So first I'll show you how to create the Hibernate application using XML. It is for XML, we need to create a Java project. So this is the example. First go to file, go to new, and create a Java project. Then give the Java name for the Java project as first Hibernate. Then inside the source, create one package com.hibernate. Then this is the Pojo class. Employee.java is the employee.java is the Pojo class where it is having the properties integer ID and string first name and the last name and the setter sign getter methods. So employee.java is the Pojo class. And this is the client application. Store data.java is the client application. And this is the mapping file uh, which contains a Hibernate mapping. Inside that the class name is com.hibernate.employee. This is package name followed by the Pojo class name. And table is employee 1000. That is, before doing that you need to go to database and create the first you need to create the table for EMP1000. Create table EMP1000 ID integer 11 primary key auto increment first name varchar 25 last name varchar 25. First create the table, then come back to Eclipse. Then here generator ID name is ID. Before property the ID tag uh, should should exist. So ID name equal to ID, generator class equal to assign, then property names are first name and the last name. Next comes these two are the XML files, mapping file and the configuration file are the XML files. These two need to be created in the source. That is, go to the source and right click on the source and go to new, other, and create the XML file inside the XML folder. Then give the names as employee.hbm.xml and hibernate.cfg.xml. And this is the configuration file hibernate.cfg.xml where hbm2 it has the property first property is hbm2 ddl.auto is update. Now what do you mean by this? HBM2 DDL auto property. This property is used to enable data definition language by Hibernate. And the different values for this property are, we have different values for this property, that is validate by default, create, second property is create, first property is validate by default, second property is create, third property is update, and fourth is create drop. Now, what is validate? Validate is a value which is used to validate the table definition, which is according to the mapping file or not. If not, then it throws the Hibernate exception. In case of validate value, Hibernate does not create any new table in the database or does not alter the existing table of the database. Next property, second property is the create property. If we use create value, then Hibernate creates a new table in the database by dropping the existing table. Then the problem with this value is while executing our application for the next time, then also the existing table will be dropped and the new table will be created always. And if we want to use HBM to DDL.auto property value as create, then for first time the execution of a Hibernate application, we should enable the property, and for next time execution, we should disable the property. And the third property is the update property. If we use update value for this property, then first Hibernate verifies whether any table is existing in the database with the same name given in the mapping file or not. If exists, then the user uses the same table, and if not exists, then the user creates a new table. Among the four values of the property, the best value is update. In the case of update value, if the existing table structure is not suitable to a given mapping file, then the Hibernate automatically alters the table structure. And the last property, the fourth property is the create drop. In the case of create drop value, create is for creating a new table and drop is for dropping the created table. In create drop value, drop works when session factory of Hibernate is explicitly closed in the Hibernate application. Otherwise, create drop value is equal to create. The, the difference between configure and configure method and configure with the string parameter. In order to load Hibernate configuration file in the client application of Hibernate, we will configure given by configuration class. Okay, so this is about the HBM to DDL.auto property. And what is Hibernate properties file? In Hibernate 1.x and 2.x version, we don't have Hibernate configuration file. Instead of it, we have properties file, and we call this properties file as a resource bundle. But the properties file is going to contain the data in the form of key space value format. In the properties file, we can add Hibernate properties and connection properties. The name of the properties file should be hibernate.properties. In a properties file, only connection and Hibernate properties can be added. We cannot add mapping files into the properties file. In a client application, when we create an object of configuration class, then configuration class will automatically search for Hibernate and loads the properties given in the bundle. It means we no need to load the properties file explicitly. In the client application, we need to add Hibernate mapping file to the configuration object explicitly by calling the add file. But what is the difference between properties file and configuration file? In a properties file, we can add the connection properties related to one database only. If at a time we want to communicate with multiple databases, then it is not possible and we cannot create multiple properties files. So in a properties file, we cannot add mapping file. So mapping file is added to the configuration object in the client application, and it is the drawback of this. Its drawback is if mapping file name is changed, then we need to modify the client application and we need to recompile the Java file or the client application. In order to overcome the above two problems with the properties file, in Hibernate 3.2x, we got configuration XML file. And next is the dialect. So, what is this dialect? Dialect, there are many dialects given for the databases, and for MySQL, dialect is given as org.hibernate.dialect.mysql dialect. And next connection.url, this is the URL for MySQL, and connection.username. This loop code is the username for the MySQL, and connection.password, loop code is the password. And next property is the connection.driver underscore class com.mysql.cj.jdbc.driver. And mapping resource is nothing but we need to configure the map the XML mapping file, that is employee.hbm.xml. So before running the application, you need to since this is a Hibernate with XML, this application is Hibernate with XML, we need to configure the jar files. So right click on the application, go to build path and configure build path, and go to libraries and then add external jars. These are all the Hibernate jar files required, and along with it you need to add a MySQL connector Java file also, jar file also, MySQL connector Java jar file. So required jar files, all the Hibernate jar files and MySQL connector jar file is also configured. Then say apply, and once you apply, go to order and export, select all the files and just say apply. After saying apply, then say apply and close. Then after configuring all the jar files, go to the client application and go to the client application. Now I'm changing the values for this. I'm setting the ID as 3 and the name as some Trump and last name as Jones. Now I'm running this client application. So just say run as Java application. So now the application is running now. It is taking some time to run the application. Okay, now the application is running now. So already the table is created in MySQL. Just this application is inserting the record with ID 3 and first name as Trump and last name as Jones. And so we need to check whether this record is inserted in the table or not. The output should be successfully saved. So we got the output as successfully saved. Then go back to MySQL and select start from EMP1000. Then see that whether this record 3 with ID 3 and first name Trump and last name Jones is inserted. So this is how you will write a Hibernate with XML. Hope you understood, and I'll continue in the next video, continue in the next class. Thank you. Hello everybody, welcome back. In the previous video, we have seen the Hibernate example using XML in Eclipse. So there are two ways of creating the Hibernate application. The first method is using XML and the second method is using annotation. So in the previous video, we have seen Hibernate example using XML in Eclipse. Now in this video, I'm going to explain the Hibernate example using annotation in Eclipse. So the Hibernate application can be created with annotation also. And there are many annotations that can be used to create Hibernate applications such as @entity, @id, @table, etc. And Hibernate annotations are based on the JPA2 specification and supports all the features. All the JPA annotations are defined in the Java X.persistence package. Hibernate Entity Manager implements the interfaces and lifecycle defined by the JPA specification. And the core advantage of using Hibernate annotation is that you no need to create a mapping or HPM file. Here Hibernate annotations are used to provide the metadata. Now I'll show you how to create a Hibernate application using annotations. So in order to create a Hibernate application using annotations, first you need to go to the file, new, Maven project. First you need to create a Maven project for Hibernate application using annotations. So go to file, new, and then Maven project. Then after clicking the Maven project, just select the workspace location here. Just select the workspace location, go to browse and select the workspace location or the folder where you want to store your Hibernate files and then say next. Then here some artifacts will be displayed here. Then select the Maven archetype. Select the Maven archetype quick start by Apache Foundation. See, select this Maven artifact ID, Maven archetype quick start with version 1.4 by org.apache.maven archetypes. Select this one and say next. Once you say next, then give the group ID as some com.annotation and then artifact ID. You can name anything as a Hibernate annotation or anything. And then say, once you give the name, you can say finish. So like that, you can create a new Maven project with the name Hibernate annotation. And this is the structure for this Maven project. You have a form.xml here where you declare the dependencies inside the form.xml. This is the form.xml where you need to declare the dependencies. Here no need to configure the jar files, just you need to declare the dependencies inside the form.xml. Now here I had declared the two dependencies here, one for MySQL connector Java and one for Hibernate core. So for this you need to go to Google. You need to go to Google and then search for in the Google you search for Maven repository. In the Google you can go for mavenrepository.com and artifact, and then here you can search for the uh, Hibernate core. You can search for the Hibernate core dependency. Once you search for the Hibernate core dependency, you get many this thing, and this is the Hibernate uh, core, Hibernate ORM, Hibernate cores. Just select this one. And here, whichever is the most usage one, you select that one. This is of 15 usages. So just select this one. Select this one, and then and this is the dependency. Just double click on this Maven dependency, then Control C. Say Control C and go back to Eclipse and just paste inside the dependencies. You can paste here inside the dependencies. Similarly, you can search for MySQL connector Java also. Similarly, you can go to Google again and you can search for go back. You can go back and search for MySQL connector dependency. MySQL connector, then you will get this MySQL connector type 4 driver for MySQL. Just select on that. Then here also you will get many many usages here. There are many usages, and select a particular usage which is the most highest one. Just click on that one and then double click on this Maven dependency, then copy Control C, say Control C, and then go back to Eclipse and then paste it here. Paste the dependency here. So this is how you will enter the dependencies into the form.xml. And then next is you have a source or source/main/java folder. First, where this package is created automatically, com.annotation.hibernate annotation, and this com.annotation is the group ID, and this hibernate annotation is the artifact ID. And then no need to create the mapping file for this. For annotation, hibernate application with annotation, no need to create the mapping file. So here there are three files. There are two files. One is Pojo class, that is employee.java, which contains the, here import javax.persistence.entity, and @entity annotation is used here. @table name is emp1000. That is automatically this table name will be created. Sorry, table table name is emp1000, where this table name is selected here. Then public class employee, then @id. We have used the properties integer id, string first name and last name, and these are the setters and getter methods. Then this is the hibernate.cfg.xml must be stored in this source folder. That is, right click on the source, then new XML file. Go to other and say XML file in the XML folder, then say next time finish. That's how you create this hibernate.cfg.xml. This is the configuration file. And here, what are the properties you have in the configuration file? First property is hpm2 ddl.auto is update, and second property is dialect, where we are using org.hibernate.dialect.mysql dialect. Third is the URL, connection.url, that is jdbc:/localhost:3306/hibernate. And the next property is the connection.username, where loop code is the username. Next property name is connection.password, loop code is the password. Next property is connection.driver_class, where this is the driver for the MySQL, com.mysql.cj.jdbc.driver. And this is the mapping class, Pojo class. So no need to create a mapping file for mapping XML file for this annotation, Hibernate application using annotation. So just go to this store data.java, which is the client application. And here again, configuration, conf equal to new configuration, create a configuration object for the configuration class, and conf.configure, and pass the configuration file inside it, hibernate.cfg.xml. Then session factory is an interface. Create an instance for session factory. Session factory equal to conf.build session factory. Then create an instance for session equal to factory.open session. Then transaction t equal to session.begin the transaction. Then an object for the Pojo class is created. Then set the values for ID, name. You set the values for ID, first name and last name. Then save these values into the Pojo class object, and save the Pojo class object into the session. Then say commit the transaction.commit. Then system.out.println successfully saved. Factory.close the factory, close the session. Then if you run on this application, just say run as the Java application. Then the application is running now. And no need to set the jar files for this Hibernate application using annotations. Just mention the dependencies in form.xml, only Hibernate core dependency and MySQL connector dependency. So successfully saved. So go to MySQL and check whether the record is inserted or not. So the following record is inserted with ID 4, first name is Mini and last name is Reddy. So this is how to create the Hibernate application using annotations. Hope you understood. So I'll continue in the next video. Thank you. Hello everybody, welcome back. Now I'm going to discuss about dialects which are used in Hibernate. SQL dialects in Hibernate. The dialect specifies the type of database used in Hibernate so that Hibernate generates the appropriate type of SQL statements. For connecting any Hibernate application with a database, it is required to provide the configuration of SQL dialect. Now, what is the syntax of SQL dialect? Property name that is in the configuration file of Hibernate, you need to mention the property name equal to dialect, and the dialect is the if whatever database you are using, the appropriate dialect you need to mention. That is org.hibernate.dialect.mysql dialect. Then end the property. So this is about dialects. Hope you understood. So I'll continue in the next video. Hello everybody, welcome back. In this class, I am going to discuss about caching in Hibernate. Hibernate caching improves the performance of the application by pooling the object in the cache. It is useful when we have to fetch the same data multiple times. And there are mainly two types of caching, first level cache and second level cache. Now, Hibernate supports caching mechanism, which reduces the number of round trips between an application and the database so that the performance of an application will be increased. Now, Hibernate supports caching at two levels. That is, first one is the first level cache or the session level, and second one is the second level cache or the session factory level. Session level cache or the first level cache is also called as the local cache or the first level cache. Session factory level cache is also called as the second level cache or global cache or JVM level cache. And Hibernate inbuilt uses first level cache, and this cache is started whenever a session is open, and this cache is dead whenever a session is closed. So Hibernate inbuilt uses first level cache, and this cache is started whenever a session is open, and this cache is dead whenever the session is closed. As a programmer, we do not need to provide any setters to enable or disable the first level cache. Whenever we try to load an object from database within a session, then Hibernate first verifies whether the object with a given ID is available within the cache memory or not. Then Hibernate loads the object from the database, and if exists in the cache memory, then instead of going to the database again, it will be loaded from the local cache memory only. And when first time we are loading an object from the database, then it will be loaded from the database only. Internally, Hibernate stores the record into a result set object, and then copies a row of the result set object into the Pojo class object, and then that Pojo class object is given to the client application and also stores into the cache memory. And when second time onwards, if we are loading the same object, then instead of loading from the database again, it will be loaded from the session cache memory only. And in Hibernate, each session has its own cache memory. It means the cache memory of one session cannot be accessed by another session. And if you want to load an object from the database again, instead of from the loader, the local cache memory, then first of all, we need to remove the object stored in the cache memory. And in order to remove an object from the cache memory of a session, then we need to call any of the following two methods, that is evict of object or clear method. And evict method is used to remove a particular object from the cache memory, and clear method is used to clear all the objects from the cache memory. And when we close the session, that is session.close method is called, then the entire cache memory will be destroyed, and it means the objects that are stored in the cache memory are also destroyed. And so this is about the cache memory, caching in Hibernate. And this first level cache is the session object, which holds the first level cache data, and it is enabled by default. So the first level cache data will not be available to the entire application. An application can use many session objects. And second level cache is the session factory object, holds the second level cache data, and the data stored in the second level cache will be available to the entire application. But we need to enable it explicitly. So what are the second level caches? Caches we are having EH cache, that is easy Hibernate cache, Swarm cache, OS cache, and JBoss cache. And Hibernate second level cache uses a common cache for all the session objects of a session factory. And it is useful if you have multiple session objects from a session factory. Session factory holds the second level cache data, and it is global for all the session objects and not enabled by default. Each implementation provides different cache usage functionality. And there are 4 ways to use second level cache. First is read only, that is caching will work for read only operation. Non-strict read write, caching will work for read and write but one at a time. And read write, that is caching will work for read and write, can be used simultaneously. Transactional, caching will work for transaction. So the cache usage property can be applied to class or collection level in HBM.xml file. So now I will explain this caching in Hibernate with an example. So first create a Maven project. That is go to file, new Maven project. Then use the default workspace location here. That is in which folder you want to store your projects. Then select the particular folder and say next. Then here the group of artifacts will be displayed. So select the Maven archetype, quick start. Select the Maven archetype quick start, which is group ID of this artifact ID is org.apache.maven.archetypes. Select this particular and say next. Then group ID I have given as com.cache and artifact ID is the Hibernate cache. And then say finish. When you say finish, the Maven project with Hibernate cache is created. Then inside the source folder, this com.cache is the group ID and Hibernate cache is the artifact ID. And this is the package created. Inside this package, first create the Pojo class employee.java. Import javax.persistent.star and import org.hibernate.annotations.cache. Import org.hibernate.annotations.cache concurrency strategy. Then mention the annotations @entity @table name equal to emp1012. Therefore, so before running this application, go to MySQL database and create the table emp1012 with integer int 10 of primary key auto increment, name varchar25 and salary is float. Then insert some values in this because our project is going to fetch the records. So insert into EMP1012 name salary with the value Scott, and this is the salary for Scott, and then another set of values Tiger, and this is the 34,354.34 is the salary for Tiger. Then go back to Eclipse. Then @cacheable, @cache usage equal to cache concurrency strategy dot read only. In public class employee @ID. Here I am taking the properties integer ID, string name and float salary. And these are the setter and getter methods. And this is the constructor. Employee constructor is used here of string name and float salary. And these are the setters and getter methods. Then in the fetch test.java, and again you need to create one hibernate.cfg.xml in the source folder. Right click on the source folder, go to new, other, and select the XML file inside the XML, say next and give the name and finish. Give the name as hibernate.cfg.xml. Then inside this Hibernate the configuration file, we have some properties like show underscore SQL is true, and hbm2 ddl.auto is update, and dialect I'm using MySQL dialect, and connection.url is the MySQL URL, and username is loopcode, password is loopcode, and the driver is the MySQL driver com.mysql.cj.jdbc.driver. And cache.use underscore second level cache. I'm using second level cache because it is true here, property is true. And cache.region.factory class is org.hibernate.cache.ehcache.ehcache region factory. And this is the mapping class which I included here. That is, we are mapping into the Pojo class of Pojo class. And next is the fetch test is the client application, and the dependencies which I included here in the form.xml is the Hibernate core dependency, and MySQL connector Java dependency, and the EHCache dependency. For EHCache, go to Maven repository and type as EHCache artifact ID, type EHCache artifact ID. Then you get this org.ehcache, select the EHCache, and select the maximum usages, select that particular version, and then copy the dependency and paste in this form.xml. Similarly, search for Hibernate EHCache also. Copy and paste the dependency. And next is the fetch test is the client application, where we have inside public static void main string args, configuration conf equal to new configuration, conf.configure. We need to configure the configuration file hibernate.cfg.xml. Then session factory equal to conf.build session factory. Then session1 equal to factory.open session. Then employee emp1 is equal to session1.load of employee.class comma this is the id, 121 is the id, and then system.out.println employee.get id, get name, and get the salary. Then get the values of this particular id. And session1.close, then I am opening a new session. You can open any number of sessions for the second level cache. You can create any number of sessions. Session2 equal to factory.open session, employee object em2 equal to session2.load employee.class comma id is 121, then system.out.println emp2.get id, and get the name and salary for this particular id, get the details of the particular id, then session2.close. So hope you understood about this caching. I'll continue in the next class. Hello everybody, welcome back. In this class I am going to discuss about versioning object. Now what is this versioning object? While updating an object in Hibernate, if you want to know how many number of times an object is updated, then we need to apply versioning mechanism given by Hibernate. If we enable versioning mechanism, then Hibernate stores the version of the object into the database into a column, so that a programmer can come to know easily about the number of times an object got updated. In versioning, Hibernate will assign the version number 0 when the object gets inserted, and then increments by 1 when our object gets updated or modified. To enable versioning in Hibernate, the following three changes are required at the application level. First, create an integer variable primitive in the Pojo class of Hibernate. Create an integer variable for version and primitive in the Pojo class of Hibernate. Then configure version element in the Hibernate mapping file, and it must be configured immediately after the ID element. Then create an additional column in the database table to store the version of an object. So I will show you this versioning object through an example. So first go to my Eclipse. Then in the Eclipse, first I went to go to the file and create a new Java project. I didn't create a Maven project for this. I had created a Java project for this. So go to file, new, and create a Java project. Then select the Java project, click say next, and give the project name as product update. I had given the project name as product update, then say finish. This is how Java project is created. Then inside the source folder, right click on the source folder and go to new and create a package. And had given the package name as com.update. This is how we'll create a package now. Inside the package, I had right click on the package now and I had created one Pojo class product.java public class product, and the properties I have used inside this Pojo class product are integer ID, string name, and double price, and in private int v. V stands for version object. And then I had declared the setters and getter methods. Then go to the source, right click on the source, go to new, other, go to new other XML file inside the XML folder and give the XML name and say finish. Then you can create two XML files like this, hibernate.configuration file and hibernate configuration file and mapping file. And this is the hibernate configuration file. Here we define a session factory. Inside the session factory, we give the property names. Here property name HBM2 DDL auto is update, and the property name dialect, I have used the MySQL dialect here, org.hibernate.dialect.mysql dialect, and property name is hibernate.show underscore SQL property is true. And next property name is connection.url. I had used the URL for MySQL, jdbc colon mysql colon / localhost colon 3306 / this is the database name Hibernate. Then property name connection.username is loop code and property name connection.password is loop code. Then property name is connection.driver underscore class. This is the MySQL driver com.mysql.cj.jdbc.driver. Then mapping resource, I'm entering a mapping file here product.hpm.xml. And next this is the mapping file product.hpm.xml is the mapping file. Inside the Hibernate mapping, I had taken the class name as com.update.product. This is the package name com.update and this is the class product. And the table, the table in the MySQL I created is products table. First you need to create the products table before running this application. Create table products. PID is the product ID, integer 10, primary key, auto increment. Then P name is the product name, varchar of 25, price is float, and version is, take one more variable here, version of integer 3. Then insert some values, two set of values into the products, insert into products, P name, price, and you need to insert version also. So I updated later as I forgot to insert. I updated the version values later. So insert into products, P name, price, and version values. Give the values for the product name is Sony. This is the price of this Sony model. And the next set of values LG product, and this is the price for LG product. Then update the version value as 0 for product ID 1 and 2. Then if you select from products, uh, products, already I updated the product ID, first record I already updated. So that's why the version is showing as 1. So before updating, the version will be 0. Now we will update the second record now. Here the version value is 0 before updating. Now we'll update and see how the version changes. And next the property, this is the version name. The table is products and ID name is ID, column is PID in the MySQL table, and generator class is assigned. Version name is V and column is VER in the MySQL table. And property name is PName and the column is PName. Property name is price and the column name in MySQL table is price. Then go to product update client.java. Inside this public static void main string words, configuration conf equal to new configuration, create an object for configuration class. Then conf.configure, inside this configure method, place the Hibernate configuration XML file, hibernate.csv.xml, then session factory equal to conf.build session factory, then session equal to factory.open session. First I am getting the ID from the product class. So we are going to update the second record. So I need to keep the ID as 2. Object O equal to session dot get product dot class comma. This is the wrapper class I am using here. New integer of 2. Then product P equal to product of O. Then transaction TX equal to session dot begin transaction. Then P dot set price. I need to set the price. I am setting the price as 97,000. And I'm setting the name of the product as Apple. Setting the name of the product as Apple, then dx.commit, then system.out.println updating, then session.close and factory.close. Since I created a Java project, this is not a Maven project, so you need to go to build, configure the build path. As this is not a Maven project, you need to go to configure build path. And first you need to add all the jar files, including the Hibernate jar files, including MySQL connector Java also. First configure all these, add all these jar files in the libraries, and then configure all these jar files. Then after configuring, say apply and then close the window. Then after this, after configuring all the jar files, right click on the product insert update client application and say run as Java application. Now our application is running now. So once the record is updated, we will get the message as successfully updated. So we got the message here updated. So we need to go back to MySQL. See here, before updating, our version is 0 for this second record. Now after updating, as we ran the application, we will see the query now. After updating, the version has changed to 1. That is, we updated both the records now, 1 and 2 records. So that's why the reason version has changed from 0 to 1. If you update once again, then the version changes to 2. That is, the version goes on incrementing as you update the records. So this is about versioning an object. Hope you understood. So I'll continue in the next class. Okay, thank you. Hello everybody, welcome back. Today in this class I am going to explain about timestamp of an object. Timestamp is a class, and this class is included in import java.sql.star package. And while working with Hibernate, it is possible to store the timestamp information of an object into the database. Timestamp information is nothing but storing the data and time of the system into the database table whenever we save an object or when we update an object. To record the data and time of the system along with the object into the database, we need to enable the timestamp facility for applications. The Pojo class create available of timestamp and generate setter and getter methods of it. Then in the Hibernate mapping file, configure the timestamp tag. immediately after the ID tab. In the database table, we need to create an additional column of timestamp for storing the timestamp information. And it is not possible to add both version and timestamp for object because we cannot write the version and timestamp tags at a time immediately after the ID tag. So in the Pojo class, we need to import java.sql package because timestamp is a class given in java.sql package. And so now I'll explain this the program. Go to Eclipse and first create a one. Go to File, go to New and create one Java project. Go to File, New and create one Java project. Then after creating the Java project with the name product insert, then go to right click on the source and create one package. Right click on the source, new package. Then give the package name as com.insert and then say finish. So like this a package is created com.insert. Then create one product.java Pojo class. This is the Pojo class. First you need to import java.sql.timestamp. Then public class product. I'm using the properties integer id, string product name, private double price and private timestamp ts. And this timestamp is used to insert the time into the database. Next, write the setters and getters for this. Then after product.java, create two XML files. One is for Hibernate configuration file and one is for mapping file. So go to source, right click on the source, go to new and other, and then select the XML file in the XML folder and say give the appropriate names and say finish. Like this, create these two files, hibernate.cfg.xml and product.hbm.xml. In hibernate.cfg.xml, you have the configuration properties. First one is hbm2 ddl.auto, it is update, and dialect is I selected MySQL dialect, org.hibernate.dialect.mysql dialect, and hibernate.show SQL is true, set to true. Connection.url, I have used a MySQL URL here, jdbc :mysql /localhost 3306, and this Hibernate is the database name. And connection.username is the loop code, connection.password, the loop code is the password, and driver class is the MySQL driver, com.mysql.cg.jdbc.driver. And I'm also including the mapping file here, product.hbm.xml. Then inside the mapping file, product.hbm.xml, you have class name is form.insert is the package name and product is the Pojo class name. Table is products1. Then ID is ID. ID name is ID. Column is PID in the database table, MySQL database. Generator class is assigned. Then immediately after ID, you need to declare the timestamp name is TS and column is tstamp in the MySQL database. And remaining two properties are property name equal to pname, column is pname, property name is price and column is price in the MySQL database. Then create one product insert, then go to this package, right click on the package and create one product insert client Java file. First you need to import org.hibernate.star and import org.hibernate.cfg.star for configuration class. Then public class product insert client begin public static void main string args configuration conf equal to new configuration. Then conf.configure, you need to uh, include the configuration file, that is hibernate.cfg.xml. Then session factory equal to conf.build session factory. Session equal to factory.open session. Then create an object for the Pojo class product b equal to new product. Then set the values for ID, name and product name and price and store it in the Pojo class object p. Then transaction tx equal to session.begin transaction. Then save this Pojo class object into the session.save of p. Then tx.commit, then system.out.println successfully inserted. session.close and factory.close. So before running this program, go to MySQL database and create a table products 1 with EID integer 10 primary key auto increment with name varchar 25 price is float and tstamp is the timestamp. So the time will be when you run the project, the time information will be inserted into the database. So this is about the timestamp of an object. So hope you understood. So I'll continue in the next video. Thank you. Hello everybody, welcome back. Today I'm going to discuss about one-to-one mapping using XML. And there are two ways to perform one-to-one mapping in Hibernate by using many-to-one element and unique equal to true attribute, using unique equal to true attribute, and by using one-to-one element. Here we are going to perform one-to-one mapping by using one-to-one element. In such a case, no foreign key is created in the primary table. And the best example for this one-to-one mapping is one employee can have only one address and one address belongs to only one employee. And here we are using bidirectional association. So we'll go into the program one-to-one mapping. First I had created one Java project with name one-to-one mapping 2. Then inside the source I had created one project com.java point. Then I had created one address Pojo class. Inside the address Pojo class, I have used the properties integer address ID and string address line 1, string city, string state, and string country, and integer pin code. And these are the one private employee. I'm creating a reference for the employee. And these are the setters and getter methods. Then after the address class, I had created one employee class, Pojo class, and this employee class contains properties, integer employee ID, string name and email, and private address. I'm creating a reference for the address class. Then I am writing the setters and getter methods. Then each employee will contain only one address and one address belongs to only one employee. And next I have created two mapping files and one configuration file. This hibernate.cfg.xml is the configuration file which contains the properties. HBM2 DDL.auto is the update and dialect I am using MySQL dialect and connection.url I am using the URL of MySQL. Username is loop code, password is loop code and driver, this is the driver for MySQL, com.mysql.cj.jdbc.driver. And I'm including the two mapping files employee.hpm.xml and address.hpm.xml. Then inside the employee.hpm.xml, I am defining the class name as package name followed by the Pojo class name of employee and table is emp212 and ID name is employee ID, generator class is increment, property name is name and property name is email. And one-to-one name is equal to address, cascade equal to all, and this is the employee mapping file. And inside address mapping file, class name is com.java2point.address and table I'm taking as address 212. And ID name is address ID, generator class is foreign, and param name is property, employee, and the property names are address line 1, city, state, country, pin code, and one-to-one name is employee. And before running this example, go to MySQL database and you need to create two tables for EMP212, EMP212, create one table for EMP212 with employee ID into 10 primary key auto increment, name is varchar50 and email is varchar50. And next create a table for address 212 with address ID integer of 10, primary key auto increment, address line 1 varchar of 100, city varchar of 50, state of varchar 50, country varchar of 50, pin code integer 6. Then after that go back to Eclipse. Then I have written two classes here. First, you need to store the records, that is store.java. First, I am using this standard service registry equal to new standard service registry builder.configure the Hibernate configuration file and metadata meta equal to new metadata sources of SSR.get meta builder.build. And after this, I'm creating an object for the employee Pojo class employee even equal to new employee. Then I'm setting the name for this employee and storing in this Pojo class object. I'm also setting the email and storing in this Pojo class object. For example, I'll set the name as Scott and I'll set the email as scott@gmail.com and some other address. And country is Australia. Then next, then create an object for the address one equal to new address, and then set the address line and store in the address object. And similarly, set the city and store in the address object. Set the state, country, and pin code and store in the address object. Then store this address one object into the employee even object. And then address one dot set employee of even and store this employee object into address one object. Then session dot persist dot even t dot transaction dot commit and session dot close. So when you run this application, you say run as Java application. The application is running now. And, it says the output is success. So you go back to this database and check whether the record is inserted or stored or not. Yes, the record is stored as employee ID is to Scott and Scott at gmail.com. And you check the address 212 table also. Address is also stored here. So again, go back to Eclipse and you can run this fetch.java also. For fetch, what we are doing, we're fetching the records and displaying the records. Here, type query equal to session.create query from employee. Create object for instance for the list interface equal to query.get result list. Then iterator itr equal to list.iterator while iterator dot has next. If any next records are there, then employee emp equal to iterator dot next. Then emp dot get employee id, emp dot get name, and emp dot get email. Similarly, address equal to emp dot get address. Then address dot get address line 1, get city, get state, get country, and get pin code. So once you run this application, then your records will be fetched now. So your two records are fetched now. So this is about one-to-one mapping. Hope you understood this program. So I'll continue in the next class. Okay, thank you. Hello everybody, welcome back. Today in this class I am going to explain about one-to-many mapping. If the persistent class has list object that contains the entity reference, then we need to use the one-to-many association to map the list element. Here we are using the scenario of forum where one question has multiple answers. So what is the example for one-to-many mapping? One question can have multiple answers. In such a case, there can be many answers for a question and each answer may have its own information. That is why we have used a list in the persistent class containing the reference of answer class to represent a collection of answers. So we'll go to the example now. First, create a Java project, one-to-many list, and inside the source, create one package called com.java t.1. Create two XML files. In the right click on the source and create two XML files. One is the configuration file, that is hibernate.cfg.xml. Here you have some properties like hvm2 ddl.auto is update, and dialect is org.hibernate.dialect.mysql dialect. Connection.url is MySQL URL I'm using. Connection.username is loop code. Connection.password is loop code. And connection.driver underscore class is the MySQL driver I'm using here. And the mapping file I included is question.hpm.xml. And if we go into this question.hpm.xml, so first the class name is package name followed by the Pojo class question. And table is Q501, ID name is ID, generator class is increment, property name is QName, and list name is answers, cascade is all, and key column is QID, and index column is type, and one-to-many class is again package name followed by the Pojo class answer. Then again inside the class name we have one more class called com.java 2.1, package name followed by answer, and table is ans501, ID name is ID, generator class is increment, and property name is answer name. Another property is posted by, and this is the mapping file. And next we go to Pojo class answer.java, where we have properties like integer ID, string answer name, string posted by, and some setters and getter methods. And inside the Pojo class question.java, we have some properties like integer ID, string question name, and private list answer. Answers is of type list. Then setters and getter methods. And first you need to store the data. In order to store the data, first create an object for answer, ANS is equal to new answer. Then ans.set answer name, Java is a programming language, and ans1.set posted by Ravi Malik. Or Java is platform high level. Java is a high level programming language, and this is posted by some squad. Next, answer. You create one more, since this is a one-to-many mapping, you need to create one more object for the answer Pojo class, that is answer2 equal to new answer. Ans2 dot set answer name is Java is robust. One more answer is Java is robust, and this is set posted by, you can give some other name. And answer, create one more object for answer3 answer equal to new answer2 gets set answer name. Here you can write it as servlet. Is servlet runs on server side. Okay, and ans3.set posted by some Jones. And then ans4 equal to new answer. Ans4.set answer name, servlet is an API, set posted by Arun. So array list, create a instance for array list. Since array list is a class, create an object for the array list. Array list equal to new array list. Add the answer1 and answer2 to the list1. Then again create an array list object list2. Then add answer3 and answer4 to list2 objects. Then create an object for question1 equal to new question1 dot set name what is Java, question1 dot set answer of list1, question2 equal to new question2 dot set name what is servlet, question2 dot set answer of list2. Then session dot persist of question1, session dot persist of question2. Then if you run this, before that you need to create two tables here. For Q501 table with ID, int10 primary key, auto increment, and question name is varchar 255, and create table for ans 501 with ID, int10 primary key, auto increment, answer name is varchar 255, posted by varchar 100, QID is int1, type is int1. So then go back to Eclipse and run this application. First you need to run this application, store data. Once the application is running now, so we got the success here inserted. So go back to MySQL and check whether the records are inserted or not. Select the star from Q501 and again what is Java, what is Servlet. And you select star from answer 501. So you will get the answers. Okay. So again go back to Eclipse and now run this fetch data. Fetch data is nothing but the iterator, create an object for iterator, itr equal to list.iterator. If iterator has any next records, then question q equal to iterator dot next. Then question name is print q dot get q name. And for printing answers, list to create an instance for list two equal to q dot get answers. Iterator 2 equal to list2 dot iterator, while iterator 2 has any next records, then answer a equal to iterator 2 dot next, a dot get answer name, a dot get posted by. So if you run this application, it will fetch all the records which are stored in the database. So it is fetching all the records which are stored in the database. So hope you understood. This is known as one-to-many mapping. So I'll continue in the next class. Okay, thank you. Hello everybody, welcome back. In this class I am going to discuss about many-to-one mapping. In many-to-one mapping, the various attributes can be referred to one attribute only. In this example, every employee has one company address and one company address only, and one company address belongs to many employees. That is, many employees belong to only one company address. So here we are going to perform many-to-one mapping using XML. So now we'll go to the program here. First create a Java project and give it the name as many-to-one mapping. Inside the source folder, create a package known as com.java 2.2, and inside that first create the three XML files. And first is the Hibernate configuration.xml, where you find the configuration properties here. First property name is hbm2 ddl.auto, which is update, and dialect is MySQL dialect, and connection.url is jdbc mysql localhost 3306 hibernate is the database name, and connection.username is the loop code, connection.password is the loop code, and connection.driver underscore class. This is the MySQL driver, form.mysql.cj.jdbc.driver. And I have mapped the two mapping files here, employee.hpm.xml and address.hpm.xml. Inside employee.hpm.xml, you find the class name inside Hibernate mapping. You find class name is com.package name followed by the employee Pojo class, com.java 2.2.employee, and the table name is emp292. ID name is employee ID. Generator class is increment. Then property name is name and property name is email. Then many to one name is equal to address. That is many employees belong to only one company address. Cascade equal to all. This is the employee mapping file, and next we go to address mapping file. Inside address mapping file, we have class name equal to package name followed by the address Pojo class name, and table is address 292. ID name is address ID. Generator class is increment. Then property name is address line 1. Property name is city. Property name is state. Property name is country. Property name is pin code. And then we have an address Pojo class here. Inside the address Pojo class, we have the properties as address ID, integer address ID, string address line 1, string city, state and country, and integer pin code. And we have one private employee reference here, employee. And these all are the setters and getter methods. And inside the employee Pojo class, we are having the properties integer employee ID, string the name and email, and the address reference, address and address. And we have the getters and setters and getter methods. Then first we need to go to store.java. Inside store.java, first transaction t equal to session dot begin transaction. Then create an object for employee Pojo plus employee even equal to new employee. And event dot set name is Ravi Malik and event dot set email is ravi@gmail.com. And then create one more object for employee class employee e2 equal to new employee, e2 dot set name equal to Anuj Verma and e2 dot set email anuj@gmail.com. Then for address, that is many employees will have only belong to one company address. That is why we have taken two employee Pojo class objects here. And address 1 equal to new address 1 set address line, this is the address, and address 1 dot set city is Noida, address 1 dot set state is UP, address 1 dot set country is India, address 1 dot set pin code is 201301. Then save this address object into the employee object. E1 dot set address of address 1, E2 dot set address of address 1. Then session dot persist of E1, session dot persist of E2, then t dot commit and system dot out dot println success. So when you run this application, first you need to add all the jar files. Go to the go to the file project and add all the jar files, required jar files. Then you go to the store application, right click on the store application, say run as Java application. Now the application is running now. So the application is running now. Yeah, the application is success now. So before running the application, you go to MySQL and create two tables. Create table EMP292 with employee ID integer 10, primary key auto increment, name varchar25, email varchar25, address is varchar25. And create one more table address 290 with address ID int 10, primary key auto increment, address line 1, varchar 255, city varchar 25, state varchar 25, country varchar 25, and pin code is 6. Then since it is success, since our application is success, it successfully inserted the data. Select star from, you check in the MySQL database. Select star from EMP292 and see whether the data is inserted or not. Yeah, the data is successfully inserted. And similarly, you see whether the address is inserted or not. Select star from address 292. Yeah, address is also successfully inserted. So after inserting, then go to fetch, then go to fetch.java and run this application. Say run as Java application. And fetch.java is going to fetch the data from the MySQL database. So application is running now. The fetch application is running. It is going to fetch the data from the MySQL database. Yeah, this is the data. So this is about many to one mapping. Hope you understood. I'll continue in the next video. Thank you. Hello everybody, welcome back. In this class, I'm going to discuss about many to many mapping. That is, we can map many to many relation either using list, set, bag, map, etc. And so here we are going to use list for many to many mapping. That is, many attributes will map are going to map many attributes. In such case, three tables will be created. So first we go to the example here. First create one Java project with many to many. And then inside the source create one package com.java 3.3 and inside another package npm create the three XML files. One is the Hibernate configuration file. The configuration file has the following properties inside the session factory. Property name is hbm2ddl.auto, which is update, and dialect is org.hibernate.dialect.mysql dialect. I'm using MySQL dialect here, and connection.url is jdbc colon mysql colon double slash localhost colon 3306 slash hibernate. This is the MySQL URL. Connection.username is loop code and connection.password is loop code. Connection.driver underscore class is com.mysql.cj.jdbc.driver. This is the MySQL driver. And I am mapping the two mapping files here, question.hpm.xml and answer.hpm.xml. Then once you go to question.hpm.xml, here the class name is package name followed by the question Pojo class. And table is question 1911. ID name is ID, type is int, and column name is q underscore id. Generator class is increment. Property name is question name. And the list name is answers. That is many questions, multiple questions may have multiple answers. This is the example for many to many. So list name is answers and table is question underscore answer of 1911. And fetch is select and cascade all. Then key column equal to q underscore id, index column equal to type, and many to many class equal to package name followed by the answer Pojo class name. And column is answer underscore id. So once we go to the answer mapping file, class name is the package name followed by the answer Pojo class, and table name is ans1911. ID name is ID, type is int, and column name is ans underscore id. Generator class is increment, and the property name is answer name, and the Another property used is posted by. So once you go to answer Pojo class, inside answer Pojo class, I am using the following properties: integer ID, string answer name, string posted by, and the list questions. Uh, List instance is the questions here. And next is the uh, question Pojo class. Inside the question Pojo class, I am using the following properties: integer ID, string name, and list answers. List instance is the answers. Then next you need to go to store data. That is, you need to store the data into the MySQL database. So first you need to create a object for the Pojo class answer. Answer ANS1 equal to new answer. Then ans1 dot set answer name is Java is a programming language. Ans1 dot set posted by Ravi Malik. Then ans2 equal to new answer. Create one more object for the answer Pojo class. Ans2 dot set answer name is Java is a platform. Ans2 dot set posted by Sudhir Kumar. Then question Q1 equal to new question. Q1 dot set question, what is question name, what is Java. Then create an object for array list. Array list L1 equal to new array list. Then add these answer objects to the array list. L1 dot add answer 1, L1 dot add answer 2. Then add this list to the question object. Q1 dot set answers of list 1. Then again create one more object for answer 3. Answer ans3 equal to new answer. Ans3 dot set answer means servlet is an interface. Ans3 dot set posted by Jay Kumar. Then create one more object for answer. Answer ans4 equal to new answer. Ans4 dot set answer name servlet is an API. Ans4 dot set posted by Arun. Then create one more object for question. Why? Because we are using here many to many mapping. That is, many questions, multiple questions have multiple answers. Question Q2 equal to new question. Q2 dot set Q name. What is servlet? Then create an object, one more object for array list. Array list L2 equal to new array list. Then add these two answer objects to the array list object. L2 dot add ans3, L2 dot add ans4. Then set the array list to the uh, question Q2 object. That is Q2 dot set answers of L2. Then session dot persist Q1, session dot persist Q2, T dot commit, session dot close, and print the success. So now when you run this, right click on the store data application and go to run as and run as the Java application. Now the application store data.java application is running now. This is going to store the following data or records into the MySQL database. So I think there are some exceptions occurring here. We'll see what are the exceptions. Question underscore ans 1911 does not exist. So you just go to answer hpm.xml or question hpm.xml, and here this does not exist. Why? Because list name is answers and the table is ans1911. So sorry, there is a mistake here. The table name is ans1911. So again stop the application, again go back to store data, then again run the application. The application is running now. Again, we are getting some exceptions here. Mapping exception. Foreign key. Foreign key must have same number of columns as the reference to primary key. Foreign key must have same number of columns as the reference to primary key. So if you get any exceptions, you please copy this exception and go to Google, copy and paste this exception and search for the solution. So this is about many to one mapping. Hope you understood, and I will stop here. Continue in the next video. Hello everybody, welcome back. In this class today I'm going to introduce Sprints. And before knowing about Spring, you need to know some concepts like what is the use of frameworks. For enterprise level business application development, Sun Microsystem has provided J2EE module. And this J2EE module contains component APIs and service APIs. Now, component APIs are used to generate or create a web component or an enterprise component. And what are the component APIs you are having? We have Servlet, JSP, and EJB. These three are the component APIs. And each component needs support of service APIs to provide service to the clients. So we call service APIs as helpers to component APIs. Then the service API provided by Sun are JNDI, JMS. JNDI stands for Java Naming Directory Interface. JMS Java Messaging Service, Java Mail, JTA, and JAAS. JAAS stands for Java Authentication and Authorization Service. Web Services Architecture and JCA. JCA stands for Java Connected Architecture. So these are the service APIs provided by the Sun. If Java programmers directly use the component and service APIs, then the programmers are getting the following problems. J2E applications need lot of application configurations and also server configurations. So it increases the burden on programmers. If any exceptions occur, then finding the root cause is difficult. So unit testing of application is difficult because server is mandatory. If any problem is occurred during the testing, then shutdown and restarting the server is required, and it makes a time consuming process. So J2E makes tight coupling between objects, and to overcome the above problems, vendors started providing the frameworks. Today we have multiple frameworks for each layer of application development. And why Spring is an alternative to EJB? EJB application development is complex and it makes use of heavyweight components for the application development. So EJBs are executed only in the server environment and these are tightly coupled objects. Spring Framework is overcoming the above problems of EJB in a simple way. Spring uses POJI or POJO model for the application development, and Spring makes the application testing easier because of its own container. And Spring provides loose coupling between the objects. Because of the above reasons, Spring Framework is far better than working with EJB. So we are calling Spring Framework as an alternative to EJB. So this is about that is before knowing the Spring, we need to know some of these concepts. So I'll continue in the next video. Hope you understood. Thank you. Hello everybody, welcome back. Today we'll discuss about Spring. What is Spring? Spring Framework is a multi-tier, lightweight application framework created by Rod Johnson to make enterprise application development as we see in Java. Spring is a complete and modular framework. It means we can develop either a particular layer using Spring Framework or we can develop complete application layer using Spring Framework. At industry level application, Spring Framework is used mostly for business logic development. For business logic development, the only framework available in the market is Spring, and otherwise we have to use EJB 3.x for implementing the business logic for industry level application. Now, Spring is a non-invasive framework. All the frameworks available in the market belong to either invasive or non-invasive. Invasive framework means it forces the programmer to extend or implement the classes from the predefined class or interface given by the framework. In case of non-invasive framework, it does not force the programmer to extend or implement their class from any predefined class or interface given by the framework. All presentation layer framework belong to invasive framework. Similarly, Spring and persistence layer framework belong to non-invasive framework. Spring Framework can be used for developing all types of Java applications. It means we can use Spring Framework in desktop application or web application or in enterprise application. But mostly Spring services are used in enterprise application development. Spring Framework runs either within a server or even without a server because Spring Framework does not depend on third-party container and it uses its own container. Spring Framework is called a layered architecture, which means one layer can be implemented using Spring, or all layers can be implemented by using Spring. And, so this is about the Spring. That is, Spring Framework is a Spring Framework is a lightweight framework. So this is about the Spring Framework. And now, what are the advantages of Spring Framework? There are many advantages of Spring Framework, like predefined templates. Spring Framework provides templates for JDBC, Hibernate, JPA, etc. technologies. So there is no need to write too much code. And let's take the example of JDBC template. You don't need to write the code for exception handling, creating connection, creating statement, committing transaction, closing connection, etc. You need to write the code of executing query only, thus it saves a lot of JDBC code. This is one of the advantages of the Spring. Next is loose coupling. Spring applications are loosely coupled because of dependency injection. Easy to test. The dependency injection makes easier to test the application. That is, the EJB or struts application requires server to run the application, but Spring the framework does not require server. Next, Spring is lightweight. Spring Framework is lightweight because of its POJO implementation, and Spring Framework does not force the programmer to inherit any class or implement any interface. That is why it is said to be non-invasive. And fast development. The dependency injection feature of Spring Framework and its supports to various framework makes the easy development of Java EE application. And powerful abstraction. It provides powerful abstraction to Java EE specification such as JMS, JDBC, JPA, and JPA. And declarative support. It provides declarative support for caching, validation, transactions, and formatting. So hope you understood. This is about the Spring introduction. So I'll continue in the next class. Okay, thank you. Hello everybody, welcome back. In this class, I am going to discuss about Spring modules. And Spring modules are six types. First one is the Spring Core. Second one is the Spring DAO. Third one is the Spring ORM. Fourth is the Spring AOP. Fifth is Spring JEE. And sixth is the Spring Web MVC. In Spring 1.x version, Spring Framework has 7 modules and Spring Web MVC are given separately. But in Spring 2.x, both Web and Web MVC modules are combinedly given as Spring Web MVC. In Spring 1.x, the module name is given as Spring Context, and in 2.x, it is renamed as Spring JEE. Spring Core module is for getting the basic functionality of the Spring. Here IOC pattern is applied and this module is called as the heart of the Spring framework. In the second module, that is Spring DAO module, is for eliminating or removing the problems with the existing JDBC technology, and it provides an abstraction on JDBC and we call it as a data access object, DAO. In the third module, that is Spring ORM, is used for integrating with ORM tools like Hibernate, iBatis for providing persistence layer. And in the fourth module, that is Spring AOP module, is for providing declarative services to Spring applications. This AOP is considered as an alternative to loops. Then fifth is the Spring JEE module, is for applying real-time uh, services to Spring Business Logic. And this module is an alternative to J2EE of Sun. It internally uses service. It internally uses service. It internally uses service APIs of J2EE. Spring. Next is the last one is the Spring Web MVC. Is either for integrating Spring with other MVC frameworks, or we can also develop complete MVC application by using this module. So this is about the Spring modules, and so we have totally six modules for the Spring. So hope you understood about this. So now I'll continue in the next video. Thank you. Hello everybody, welcome back. Today I'm going to explain Spring example in Eclipse. Here we are going to create a simple application of Spring framework using Eclipse IDE. And let's see the simple steps to create the Spring application in Eclipse IDE. First create the Java project, then add the Spring jar files, then create the class and create the XML file to provide the values, property values, and create the test class. So we'll go and see the example for the Spring. First you need to go to file, then go to new and create a new Java project. Then give the name for the project as Spring. I have given the name of the Java project as Spring. Then inside the source, create one package com.spring. Inside this package, create one Pojo class for the student. The student is the Pojo class, and I have used the properties, only one property, that is string name. And these are the setters and getter methods for the name. And this is the public void display info is the method where it is printing hello plus name. And this is the application context.xml file which you need to create in the source. Go to source, right click on the source, new, and go to other, then create one XML file in the XML folder, and give the name as application context.xml file. Then inside the application context.xml, we are having the beans. Inside the bean stack, we are having the bean ID is student bean, and class is package followed by the Pojo class, that is com.spring.student. What are the properties we are using in this Pojo class? Property name is name and value equal to Vimal JS1. So this is the application context.xml. Then go to the client application, that is test.java, and the public class test to begin public static void main string args. Create an object for the resource equal to new class path resource, and push the application context.xml file in this method. Then bean factory equal to new XML bean factory of resource, and student equal to factory dot get bean of student bean. You get this bean from the application context.xml. Then student dot call the display info method of the using the student object. Now just you need to add the jar file. So go to the project root folder, right click, go to build path, and then say configure build path. Inside configure build path, you need to download the Spring jar files, Spring core jar files, and you need to add the external jars, that is Spring core jar files, and say apply. Once you say apply, go to order and export and select all, and then say apply. Select all the jar files and say apply and close. Then you can run this test application, client application, right click on the test application, run as Java application. We are not using any server for this Spring. Just run as Java application, and here we get the output as hello Vimal Jaiswal. So this is the first Spring application in Eclipse. Hope you understood. I'll continue in the next video. Thank you. Hello everybody, welcome back. In this class, I'm going to discuss about IOC container. Before that, you need to know about the Spring Core. When one Java class service is dependent on another Java class service, then it is known as coupling. That is, if one class is calling the business method internally of the other class, then it is known as coupling. Now, what is type coupling and loose coupling between the objects? While developing non-trivial applications, that is complex applications in Java, one class will collaborate with another class to provide service to the end user. In Java, one class is collaborating with another class is nothing but one class is calling the business method of another class. And if one class is calling a method of other class, then say that both the classes are coupled together. Generally, when one Java class is depending on another Java class, then that Java class will create an object of its dependent class and then calls the service method of that class. Now, what is type coupling? For example, if we have a class traveler and class car, then I had created a car object inside the class traveler. So in the above example, traveler class is depending on the car class to provide a service to an end user called journey. So car class is called dependency of traveler, and we also call the car class is as a collaboration. Now, what is type coupling? In the above example, traveler class is tightly coupled with the car class. Why? Because the car class object is created inside the traveler class. It means if any changes are done in the car class, then accordingly to that the changes are needed or required in the traveler class also. For example, why? Because traveler class is depending on the car class. And for example, if go method is replaced with start method in car class, then in start journey of traveler, we need to call the start rather than the go method. And so if we directly create the dependent object required in a class, then also we get tight coupling between the objects. For example, if we want to replace car with motorbike in traveler class, then we need to create motorbike object by removing the car object. Then what is loose coupling? In tight coupling between objects, if dependent object is modified, then the main object also needs to be modified. To avoid tight coupling between objects, we need to follow the interface that is POJI and implemented class POJO method. If we follow POJI or POJO model, then it is possible to get loose coupling between the objects. In the above example, to get loose coupling between traveler and car classes, we need to rewrite the application like the following. That is, class traveler is there, and we need to create an interface vehicle which contains void start method, and class car implements the vehicle, and class bike implements the vehicle, and class flight implements the vehicle. And this vehicle instance is created inside the traveler class. So this is the example for loose coupling. And in the above example between traveler and the vehicle, we got loose coupling between the objects. It means vehicle is an interface and we can inject any one of its pre-implemented class objects at runtime, and we can provide the service to the end user called journey. The dependent object is externally injected by calling its setter method. And so in the traveler class, no changes are required. And if we want to change a vehicle from car to bike, then this concept is called loose coupling between the objects. Spring Framework promotes loose coupling between the objects only by following the POJI or POJO model, and hence Spring is said to be the most popular framework for the development of enterprise level applications in Java. Finally, in tight coupling, we got the following problems. If any changes are done in the dependent object, then according to that, main object needs to be changed. And tight coupling makes unit testing of an application as complex. So in order to avoid the above two major problems, we need to apply loose coupling between the objects, and it is possible through POJI or POJO model. Now what is this inversion of control? IOC stands for inversion of control. IOC is of two types, pulling or taking, that is dependency lookup, and pushing or given, that is dependency injection. While developing Java applications, generally one object needs a service from another object, and we call this concept as object-to-object collaboration. In Java, there are two approaches to get its collaborated objects by a main object. First approach is an object can create its collaborated, that is on dependent object required explicitly by itself, or an object can take its dependent objects required from an external resource like a registry. And second approach is an external entity can provide the dependent objects required into the main object. And the first approach is called the dependency lookup, and the second approach is called the dependency injection approach. In dependency lookup, we have pulling an object or taking an object operation, and in dependency injection, we have pushing an object or giving the object operation. So both lookup and injection are parts of IOC, but mostly the form IOC is used with dependency injection pattern. In dependency lookup, an object explicitly creates another object which has a relationship, or it can take the required object from the JNDI registry. For example, in connection pooling, Java client application depends on data source objects in order to get connection pooling service. In this case, our Java client application goes to JNDI registry and performs a JNDI lookup operation and gets the data source object required from the registry. So we call this type of IOC as dependency lookup. Spring follows mostly dependency injection, that is by reading the Spring config file, that is the XML file, and by reading it, the Spring container knows what to inject from A to B. In XML file, all the classes are defined, dependencies are constructed. What is the Spring Core container? In Spring Framework, we have following two Spring Core containers, that is Bean Factory and Application Context. Bean Application Context is the sub of Bean Factory. Both Bean Factory and Application Context are interfaces, and Application Context interface is extended from the Bean Factory interface. Application Context is said to be derived interface of Bean Factory. Spring Framework has provided the implementation classes for all the interfaces it has provided. In all the frameworks, interfaces and their respective implementation classes will be provided by framework. In Spring Framework, we have multiple implementation classes for Bean Factory interface, and we mostly use implementation class as XML Bean Factory. Application context interface is also containing multiple implementation classes, and we mostly use implementation class as class path XML application context. And steps to create the client application. What are the steps to create the client application? Step one is to create an object of resource. Here resource is an interface and class path resource is an implementation class. Both are given by Spring Framework. And step two, the resource is an interface and its implementation class is class path resource. Both are given in org.springframework.core.io package. And step three is while constructing resource object, we need to pass Spring configuration file name as parameter. That is resource object equal to new class path resource of application context.xml. Then step 4, create Spring Core container IOC container object by passing resource object as a parameter. Step 5, Spring Basic Core container is identified with interface Bean Factory, and we mostly use implementation class called XML Bean Factory for creating an object of Bean Factory. And step 6, the bean factory is interface given in Spring Framework.beans.factory, and XML bean factory is an implementation class given in Spring Framework.beans.factory.xml package. That is bean factory object equal to new XML bean factory of resource object. Step 7, call getBean and the method and pass ID of the bean as a parameter to get required bean object by client. And when we call getBean, then internally Spring Container IOC will do the following. First, the container verifies whether any dependent object required for this bean or not. If required, then creates dependent object first. Then now creates the requested bean object by client. Then injects all the dependencies required by using the constructor or setter injection. And finally, the requested object will be given to the client. And step 8 is typecast object into our Spring Bean class type. And step 9 is call business method of Spring Bean object. So this is about the injection of control IOC. So hope you understood. I'll continue in the next class. Thank you. Hello everybody, welcome back. In today's class, I'm going to discuss about dependency injection. Dependency injection is a design pattern that removes the dependency from the programming code so that it can be easy to manage and test the application. Dependency injection makes our programming code loosely coupled. And what are the problems of dependency lookup? There are mainly two problems of dependency lookup. Tight coupling, that is, the dependency lookup approach makes the code tightly coupled. If the resource is changed, then we need to perform a lot of modification in the code. And second reason is not easy for testing. This approach creates a lot of problems while testing the application, especially in black box testing. And the dependency injection is a design pattern that removes the dependency of the programs. In such case, we provide the information from the external source such as XML file. It makes our code loosely coupled and easier for testing. And there are two ways to perform dependency injection in Spring Framework. That is, the Spring Framework provides two ways to inject the dependency. First is by constructor method, second is by the setter method. So hope you understood about this dependency injection. We'll continue in the next class. Hello everybody, welcome back. In this class, I'm going to explain about constructor injection. We can inject the dependency by constructor also. The constructor arg is the sub-element of the bean tag, and this is used for constructor injection. Here we are going to inject primitive and string-based values, dependent object, and collection values, etc. First, we'll see how to inject the primitive values using the constructor injection. So for this, we can first you need to create a Java project by name dependency injection by constructor. Then inside the source, create one package com.construct com.cons, and inside this package create three files. That is, first one is the address file, which is the Pojo class of address, and here contains the properties string city, string state, and string country. And create a constructor, parameterized constructor for address, public address with string city, comma string state, comma string country as arguments. And then begin this dot city is assigned to city, this dot state is assigned to state, and this dot country is assigned to country. Then public string to string method. Inside this method, we are returning the cities plus state plus country. And inside employee Pojo class, we have properties integer id, string name, and address. That is, we are just creating the reference for the address class, or just we are creating the instance for the address class. Then create a constructor. This is a default constructor, and create one parameterized constructor for the employee with public employee int id, string name, and address. Then begin. super method, call the super method, then this dot id is assigned to id, this dot name is assigned to name, and this dot address is assigned to address. Then we have defined one more show method where we are printing the id and the name, and we are calling address dot to we are calling the toString method of the address class. And next is the test dot. First we need to create one XML file, application context.xml, by right clicking on the source and create one XML file with name application context.xml. And inside this application context.xml, bean id is a1, class is package name followed by Pojo class address. Then constructor, inside the bean tag we need to define constructor arg value equal to address Ghaziabad and constructor arg value equal to UP, constructor arg value equal to India. And inside one more bean tag id equal to e and class equal to com package name followed by the employee Pojo class. Then inside the bean tag define the constructor arg value equal to 12. 12 is the id and type is integer, and constructor arg value equal to Sonu. Sonu is the name of the employee. Then reference bean is equal to A1. Then go to the test application. Inside the test application, first create object for resource r equal to new class path resource and pass the XML application context.xml file into this method. Then bean factory equal to new XML bean factory and pass the resource object. Then employee s equal to factory.get bean. Get the employee bean here, and then start show. When you run this application, right click on this test application, run as the Java application. Then here you will get the employee ID, name and the address. So hope you understood. This is about the constructor injection. So I will continue in the next class. Thank you. Hello everybody, welcome back. In this class I am going to explain about constructor injection with dependent object. If there has a relationship between the classes, then we create the instance of the dependent object first and then pass it as an argument to the main class constructor. Here our scenario is employee has a address, and address object will be termed as the dependent object. So now I'll explain about this example. First, create a Java project with dependency injection with dependent object, and then inside the source create one folder package called com.object, and then in the source right click on the source and create one XML file, name it as application context.xml. Inside this application context.xml we have bean id equal to address 1 and class is package name followed by the Pojo class address. Then constructor arg value equal to the address 21 comma Lohia Nagar. Constructor arg value equal to Ghaziabad. Constructor arg value equal to UP. Constructor arg value equal to USA. And then next bean id equal to E1, class equal to com dot object dot employee. That is package name followed by the employee Pojo class. Then constructor arg value equal to 101. Constructor arg value equal to Sachin. Constructor arg reference equal to address 1. Since this address is the dependent object, we need to take the reference. We need to put the address 1 as the reference here. And next, if you go to the address Pojo class, I'm using the properties as string address line 1, city, state, and country. Then you need to create a parameterized constructor for address with string address line, string city, string state, and string country. Then begin call the super method. Then this dot address line 1 equal to address line 1, this dot city equal to city, this dot state equal to state, and this dot country equal to country. Then create one method called toString method and return address line 1, city, state, and country. Then inside the employee Pojo class, I'm having the properties integer ID, string name, and address reference instance I have created for the address or the reference. Then create one parameterize constructor for the employee with integer ID, string name, and address, and begin call the super method, and then this dot id is assigned to id, this dot name is assigned to name, this dot address is assigned to address. Then create one method called void show. Inside that, print the id and name along with the address. Then go to the test application. Here resource are equal to new class path resource and pass the application context.xml file. Then bean factory equal to new XML bean factory of the resource object. Then create one object for employee e1 equal to factory.getBean of e1. Then e1 dot show. And if you right click on this test application and just say run as Java application. Then you get the output as employee ID, name, and the address. So this is the dependency injection with dependent object. So hope you understood, and I'll continue in the next class. Hello everybody, welcome back, and in this class I am going to explain the constructor injection with collections. We can inject the collection values also by constructor in the Spring framework, and they can use three elements inside the constructor arg element. uh, that is, it can be list, set, or map, and each collection can have string based and non-string based values. So for example, we can go to the Eclipse. First create a Java project with dependency injection with string-based collection. Inside the source, create one package com.collection, and first create an XML file. Right click on the source and create an XML file and name it as application context.xml. Here bean id equal to q and class equal to com.collection.quotient, that is package name followed by the Pojo class name question. Then constructor arg value equal to 111. Constructor arg value equal to what is Java. Then since we are using the constructor injection with collections, we have to use a list tag inside the constructor arg. And the list value is Java is a programming language, Java is a platform, and Java is an island of Indonesia. So end the list and end the constructor argument. Then this is the Pojo class question, and we are using the properties int id, string name, and list answers. And create one parameterized constructor for the Pojo class question with int id, string name, and list answers. And then call the super method, and this dot id equal to id, this dot name equal to name, this dot answers equal to answers. Then create one method public void display info, and then print the system.out.println id and name, and the answers. For answers, to print the answers, create one iterator object, iterator itr equal to answers dot iterator. Since answers is a list instance, we have an iterator method for this instance. So call this method answers dot iterator. While itr dot has next and system, if it is checking whether iterator has any next records. If it is having any next records, then system.out.println itr.next. Then go to our client application test.java, where go to our application test.java, and here resource are equal to new class path resource and pass the application context.xml file inside this method. Then bean factory equal to new XML bean factory of the resource. Then question q, create an object for the Pojo class question. Question q equal to factory.getBean of pass the bean id. Then q.display info. And you need to set this, go to build path, and you need to set the jar files for the Spring core. So these are the Spring jar files. First we need to set the jar files. And if any error comes, then just If any error occurs, just go to Google and copy paste the error and search for the solution. So this is about the dependency constructor injection with the collections. So hope you understood, and I will continue in the next class. Thank you. Hello everybody, welcome back. In this class I am going to discuss about setter injection. We can inject the dependency by setter method also. The property sub-element of the bean tag is used for setter injection. Here we are going to inject primitive and string-based values, dependent object and collection values, etc. So first we'll go to this Eclipse and first create one Java project with dependency injection by setter method, and inside the source create one package called form.setter. Inside form.setter create one Pojo class with employee, and the properties used inside this employee class are integer ID, string name and string city, and then write the setters and getter methods, and then you define one display method where you print the ID, name and city. Then create one XML file by right clicking on the source. Create one XML file and name it as application context.xml. And in the application context.xml, we have bean ID equal to object, class equal to package name followed by the Pojo class name, that is com.setter.employee. Then property name is ID, value is 20, and property name is name, and some value is Arun. Property name is city, value is Ghaziabad. Then end the bean, and then go to test application. A resource, create an object for resource R equal to new class path resource and pass the application context.xml file into this method. Then bean factory equal to new XML bean factory of the resource object. Then create a Pojo class object employee equal to factory.getBean of the object. You get the bean object here, and then e.display. So right click on this test application, then say run as Java application. Okay, then the ID, name and the address of the employee is displayed. So this is about the setter injection. Hope you understood, and I'll continue in the. Hello everybody, welcome back. In today's class, I am discussing about setter injection with dependent object. Like constructor injection, we can inject the dependency of another being using setters. In such case, we use property element. Here, our scenario is employee has a address. The address class object will be termed as the dependent object. So now I'll show you with the setter injection with dependent object with an example. Go to Eclipse and create a Java project and name it as setter injection with dependent. Inside the source, create one package called form.dependent, and inside this first right click on the source, create one XML file and name it as application context.xml. Inside the application context.xml, the bean ID equal to address 1, class equal to form.dependent.address, that is package name followed with the Pojo class name address. Then property name equal to address line 1, value equal to 51 Lohianagar. Property name is city, value is Ghaziabad. Property name is state, value is UP. Property name is country, value is India. Then take another bean ID equal to object and class equal to package name followed by the employee Pojo class. Then property name is ID, value is 1. Property name is name, value is Sachin, and property name is address, and reference equal to address 1. Why? Because employee contains this address as the reference. That is why we need to use the reference equal to address 1. Then in this address class is a Pojo class which contains the properties private string address line 1, city, state and country. Then these are the setter and getter methods. And at last we have a toString method. You need to create one toString method to return the address line, city, state and country. And this is the employee Pojo class where you have the properties integer ID, string name, address. These are the setter and getter methods. And create one method display info where you print the ID and name and the address also. Then go to test application where application context factor equal to new class path XML application context and pass the application context.xml file into this method. Then employee equal to factory dot get bean of object, get the bean ID here. Then e dot display info. Now right click on the first you need to click on the project and right click on the project and configure build path and add the right click on the project, go to build path, configure build path and set all the jar files. Then after setting all the jar files, right click on the test application project and run as the Java application. Now the application is running now. So here ID, name is Sachin Yadav and his address is displayed. So this is about the setter injection with the dependent object. So I'll continue in the next video. Thank you. Hello everybody, welcome back. In this class, I'm going to discuss about setter injection with collections. We can inject collection values by setter method in Spring Framework. There can be used three elements inside the property element. It can be list, set, and map. Each collection can have string-based and non-string-based values. So first we'll go to Eclipse and first create a Java project, setter injection, and name it as setter injection with collection. And inside the source folder, create one package form.setter injection with collection. And in, right click on the source and create one XML file and name it as application context.xml. In this application context.xml, we have bean ID equal to q and class equal to package name followed by the question Pojo class. Property name is ID, value is 1, property name is name, value is what is Java, and property name is answers. And inside the list tag, since we are using collections here, for the collections we are taking a list. And inside the list tag value, we are taking value as Java is a programming language, value Java is a platform, and value Java is an island. Then end the property and end the bean tag. Then in the question the Pojo class, question.java, there I have defined the attributes integer ID, string name, and list answers. And then these are the getter and setter methods. And I have created one public void display info where I printed the ID and name, and the answers I printed by taking the iterator object, that is iterator itr equal to answers dot iterator. Since answers is an instance of the reference to the list, the it contains an list contains an iterator method. This instance contains an iterator method. So it is checking the condition while iterator dot has next. That is, if this iterator has any next records, then system dot out dot println iterator dot next. Then go to the test application on Java and then here resource r equal to new class path resource and pass the application context.xml file in this method. Bean factory equal to new XML bean factory of resource object. Then create the object for question Pojo class. Question q equal to factory dot get bean of get the bean ID here. Q dot display info. Then call the display info method of the bean class or Pojo class. Then right click on the test application and first you need to configure the jar files. Then right click on the test application and say run as Java application. Then the Java application is running now. The test Java application is running and we got the output as first ID, question ID is 1. And what is Java is a question and the answers are Java is a programming language, Java is a platform, and Java is an island. So this is about the setter injection with collections. Hope you understood, and we'll continue in the next class. Hello everybody, welcome back. In this class I am going to discuss about auto wiring. Bean wiring means configuring the bean along with its dependencies into XML file. In bean wiring, the programmer is responsible to configure all the bean properties into XML file. In case of bean auto wiring, Spring IOC container will automatically wire the dependencies which are in the form of objects. It means auto wiring is supported only for objects dependency and not for primitives and connections. And there are the scopes. What are the advantages of auto wiring? It requires the less code because we don't need to write the code to inject the dependency explicitly. And disadvantage of auto wiring is no control of programmer and it can't be used for primitive and string values. And the scopes which are used for the auto wiring are by name. First is by name. In this type of auto wiring, the Spring container verifies whether the bean in the container whose ID is matched with the property to be injected or not. And if matched, then the container injects that bean object into the main object by calling the setter method. If no bean is found in the container with the ID as equal to the property name, then that property uh, remains unknown. So then the next scope is by type. In this type of auto wiring, Spring Container verifies whether a bean class name can be configured in XML and property type to be injected are matching or not. If matched, then container injects the class object by calling the setter method of the class. If no class is matched, then property remains unwired. And next scope is constructor. In this type of auto wiring, Spring Container verifies whether class name in the configuration is matching with the property type to be injected or not. If matched, then injects that class object by calling the constructor of the class. If no class is found with property type, then throws unsatisfied dependency exception. Both by type and constructor functionality is same, but the by type uses setter injection and constructor uses constructor injection. And the next one is the auto detector. In this type of auto wiring, Spring Container tries to work like a constructor, and if not, then works like by type. It means if there is a constructor in the class, then works like constructor, and if there is a setter in the class, then works like the by type. If the class contains both constructor and setter, then the first preference will be given to constructor auto wiring. And the common points of auto wiring are by name and by type auto wiring uses setter injection. And by type and constructor auto wiring checks for class name but not for its ID. In by name auto wiring, there is no chance of getting unsatisfied dependency exception because we cannot duplicate the bean ID in XML file. And if you don't specify, then the default auto wire is none. It means explicit wiring is required. If dependency is in the form of objects and also in the form of primitives or collections, we should combine both auto wiring and explicit wiring. And so this is about the auto wiring. So hope you understood. I will continue in the next class. Thank you. Hello everybody, welcome back. In this class I am going to explain about Spring MVC. Spring MVC, that is Model View Controller, is a Java framework which is used to build web applications. It follows the Model View Controller design pattern. It implements all the basic features of a core Spring framework like inversion of control, dependency injection, and the Spring MVC provides an elegant solution to use MVC in the Spring framework by the help of Dispatcher Servlet. Here, Dispatcher Servlet is a class that receives the incoming request and maps it to the right resource such as controllers, models, and views. Now, what is a model? A model contains the data of the application. A data can be a single object or collection of objects. Controller. A controller contains the business logic of an application. Here, at the rate controller annotation is used to mark the class as the controller. View. A view represents the provided information in a particular format. Generally, JSP plus JSTL is used to create a view page. Although Spring also supports other view technologies such as Apache Velocity, Timely, and FreeMarker. Friend controller. In Spring Web MVC, the dispatcher servlet class works as a friend controller. It is responsible to manage the flow of Spring MVC application. Now we'll go to Eclipse and see how this Spring MVC works. First go to File, New, and then create a Maven project. First go to File, New, and create a Maven project. Then after creating a Maven project, Spring MVC, inside the source folder, create a package called com.mvc, and inside this package, create one hello controller.java. And in this controller, first the control starts from web.xml. Here, the servlet class, the web.xml control sends to the dispatcher servlet. Here, the servlet name is Spring and servlet class is org.spring framework.web.servlet.dispatcher servlet, and load on startup is 1 here. And servlet inside servlet mapping, the servlet name is Spring and URL pattern is /mvc. And from web.xml, the control goes to Spring servlet.xml. Here the context component scan base package is com.mvc. From the dispatcher servlet from web.xml, it creates a object for model and view, and the controller then goes to hello controller.java, where at the rate request mapping is this is the URL for the hello controller.java, that is at the rate request mapping of /mvc. Then public string display, then return the index. Then inside the form.xml, you mention the dependencies here. The dependencies are Tomcat Jasper, org.group ID is org.apache.tomcat, and artifact ID is Tomcat Jasper, version 7.0.12. And another dependency is group ID is javax.servlet, artifact ID is servlet API, version is 3.0 alpha 1. Then mention these dependencies, and then inside the index.jsp, I have written welcome to Spring MVC tutorial. Now right click on this index.jsp. Since this is a Maven project, no need to configure the build path. That is, no need to configure the jar files. Just you need to add the dependencies in the form.xml and just run on the server. You need to run this MVC application inside us. You need to deploy into the server and then run using the server, Tomcat server. Then say next and select the appropriate project and say finish. Then we'll get the output as welcome to Spring MVC tutorial. So this is about the Spring MVC. Hope you understood. So I'll continue in the next video. Thank you. Hello everybody, welcome back. In this class, I'm going to explain about Spring MVC CRUD. CRUD stands for Create, Read, Update, and Delete. And CRUD application is the most important application for creating any project. It provides an idea to develop a large project. In Spring MVC, we can develop a simple CRUD application. And here we are using the JDBC template for database interaction. So we'll see the CRUD application in Eclipse. So first go to Eclipse and go to File, just go to New and create a Maven project. Go to File, New, and create a Maven project. So I explained how to create a Maven project in the previous videos. Then name it as Spring MVC CRUD Simple. And inside the source folder, create one package called com.java t.beans. And inside that, you write the Pojo class for employee.java, and EMP is the Pojo class, and it contains the properties integer ID, string name, float, salary, and string designation. And these are the setter and the getter methods. Then after the Pojo class, then the create one more package called com.java tpoint.controllers. Inside that, create a file called empcontroller.java, and then create one more package called com.java tpoint.dao, and create one empdao.java. Now first here we have some JSP files inside the webin folder. There is one JSP folder. Inside the JSP we have emp edit form.jsp, emp form.jsp, and view emp.jsp. And inside the web app we are having one index.jsp also. And there is one form.xml file. Inside the form.xml you need to declare all the dependencies. So what are the dependencies we have taken here? We have taken the dependencies. One is Spring Web MVC, where group ID is org.spring framework and artifact ID is Spring Web MVC, and the version is 5.1.1 release. And next dependency is group ID is org.apache.tomcat, and artifact ID is Tomcat Jasper, and version is 9.0.12. And the next dependency is group ID is javax.servlet, artifact ID is servlet API, version is 3.0 alpha 1. And next dependency is group ID javax.servlet, artifact ID is JSTL, and version is 1.2. And one more dependency is group ID MySQL, and artifact ID is MySQL connector Java, and version is 8.0.11. So these are the dependencies. And one more dependency is there. Group ID is org.spring framework. Artifact ID Spring JDBC. Version is 5.1.1 release. And these are the dependencies you need to add into the Spring form.xml file. And then after adding the dependencies, first the control goes to the web.xml. First, always the control goes to the web.xml. Inside the web.xml, I had configured the dispatcher servlet. That is, servlet name is Spring and servlet class is org.springframework.web.servlet.dispatcher servlet. I have configured the dispatcher servlet, and the control goes to the controller through dispatcher servlet. So first the controller goes to controller from the web.xml through dispatcher servlet. First, the control starts from index.jsp. So here in index.jsp, ahref equal to emp form is the URL for add employee, and ahref is view emp for view employees. So once I click add employee, the control goes to the controller through dispatcher servlet. So now at the rate controller public class emp controller at the rate autowired emp DAO object, and request mapping is emp form. So first when you say the index.jsp, when you say add employee, then it will go to the dispatcher servlet. The control goes to the emp controller through dispatcher servlet, and emp form is the URL for this employee controller. Then public string show form of model M, then m dot add attribute of command comma new emp, then return emp form. Then it will go to the emp form, show form emp form. So it goes to the emp form. Inside the emp form, add a new employee, then form method equal to post, action equal to save, and name form input path is name, salary form input path is salary, designation form input path is designation, and input type is submit. Once you say submit, the form action goes to the emp DAO method. Then inside emp DAO, it goes to the save method of the emp. Why? Because inside the controller, uh, we have the, once we say return EMP form, then the control goes to the request mapping and value equal to save slash save method equal to request method dot post. So it goes to the save method of the EMP DAO. Save method of EMP DAO, and inside the EMP DAO, public int save of EMP key string SQL equal to insert into EMP99. This EMP99 is the table first you need to create in the MySQL. Before running this application, you need to create a table EMP99 in MySQL with ID into 10 primary key auto increment, name varchar of 50, salary float, and designation varchar of 100. I created the table for EMP99. Then go back to Eclipse. Then here insert into EMP99 name, salary, designation, values. You get the values from the EMP Pojo class. P dot get name plus P dot get salary and P dot get designation. So once you get the data from the Pojo class EMP, then return template dot update of SQL. Then this goes to the update method. Then it goes to the EMP. Okay, after inserting the records, it will again go back to the EMP controller, and it will save model attribute EMP. It will save the results here, and DAO.save EMP. After it will store the result in the DAO object, and it will say result redirect to view EMP. Then once it says redirect to view EMP, the control comes here, the down where request mapping is view EMP. Then public string view EMP of model and begin list equal to DAO dot get employees. Then it goes to the get employees method of the DAO. Inside this DAO, EMP DAO, this is the get employees method where we get return template dot query select star from employee 99 comma new row mapper of EMP and public EMP map row result set RS comma int row throws SQL exception. Then create an object for Pojo class and what are the data which are stored in the result set. That is, this query is executed and stored in this result set object. Then the records in the result set are stored in the Pojo class object EMP. Then you say return E. Then once you say return E, the result is stored back into this. The result is stored into this EMP object. Sorry, where is that get employees? Okay. So once you call DAO.get employees, results is stored in the list object, and then m.add attribute the list to the list attribute. Then return view EMP. The next at the rate request mapping goes to the EMP edit form. Then once you click on the edit, it goes to the edit form, and edit employee form method is post, and form path is ID, form input path is name, form input path is salary, form input path is designation. And once you submit, then the action goes to Spring MVC correct simple edit save. Then it goes to edit save of EMP controller. Then the control comes here, and then call the update method of DAO. Then it goes to the update method of DAO. Inside EMP DAO, there is an update method where string SQL equal to update EMP99 set name equal to p dot get name, salary equal to p dot get salary, designation equal to p dot get designation. Then return template dot update of SQL. Once you update it, first you get the employee by ID inside the controller. First get the employee by ID and store it in the Pojo class object, and then go to return to EMP edit form. Inside EMP edit form, it will submit inside EMP edit form. Once you submit all these details, the control goes to edit save of employee controller. Then inside the edit cell, the control comes here and it goes to update method of DAO, where the update method inside the DAO, the update query is written here, where the records get updated. Then control again comes back to employee controller and return to redirect view EMP. View EMP means again the control goes to this view emp.jsp. Here again the employees list is given. Table is taken with the name, salary, designation, edit and delete. Then for each C colon for each var equal to EMP, items are stored in the list. Now PD, emp.id, emp.name, emp.salary and emp.designation. Once you click on the edit, it goes to edit EMP. Once you click on the delete, the URL goes to delete EMP of the employee controller. It goes to delete EMP, and inside the delete EMP, there is a delete method here, and it goes to delete method of employee DAO. And inside employee DAO, this is the delete method where string SQL equal to delete from EMP99 where ID equal to ID. Then return the update.sql into the template. And again control goes back here, and then it will again redirect to the view EMP. So this is how we can view the employees. We can view the employees. So now first we'll run this application. In order to run the application, no need to set any jar files because we created a Maven project. So only set the dependencies in Code.xml and right click on this index.jsp application. Just say run as run on the server. Select the Tomcat server, say next, then click on Spring MVC CRUD and say finish. Then the application is running now. So we require a server for this MVC CRUD application. So the application is running now. Once the application is run, here it's saying server Tomcat at localhost was unable to start within 45 seconds. It requires more time. So if it requires more time, double click on this server. Double click on this server, then go to timeouts and increase the timeout of the increase the timeout. Okay, after increasing the timeout, just save it and then close it. And again restart the server. Again start the server. And after starting the Tomcat server, after starting the server, right click on the application index.jsp and say run as, run on the server, select the Tomcat server and select the appropriate project, Spring MVC CRUD project and say finish. Then here we get add employee and view employees. First click the add employee. Then here it will ask for the employee name. So I'm entering Scott as the employee name and salary putting some salary here, and designation is the manager. Putting the designation as manager and say save. Once you click the save button, then you can view the employees list here. If you want, you can add one more employee, but I'll show how to edit now. If you click on the edit, you can change the salary. If you can modify any field, if you want, you can modify any field. So I'm modifying the salary now. I'm saying edit save. So the salary is modified, and you can also delete by clicking on the delete. You can delete the record. So this is the MVC CRUD application. Hope you understood this. So I'll continue in the next class, next video. Then thank you. Hello everybody, welcome back. Today I'm going to explain a Spring project, and the project name is Vehicle Insurance System. And first create a Maven project with Vehicle Insurance System. Then inside the source main Java folder, create one package called config package, where you have hibernate config.java, and this hibernate config.java contains the configuration properties like database URL, which is the MySQL database I'm using here, MySQL URL, that is jdbc colon mysql colon /localhost colon 3306 / spring. Spring is the database here, database name. And next is the database driver is the MySQL driver, that is com.mysql.cj.jdbc.driver. And database dialect is the MySQL dialect, that is org.hibernate.dialect.mysql dialect. And database username is loop code, and database password is the loop code. And this is the configuration information, which is written inside the Hibernate config. Then next is the MVC web application initializer.java class, and next one is the security web application initializer, web config, and web security config. These all are the config applications, configuration applications. Next, the control starts from the here there are some, these are the controller classes, and these are the DAO classes, and these are the model classes. And first the control starts from the home.jsp. First the controller starts from home.jsp, where the this user details, and it contains all this search details, vehicle details, and user details. So first the control starts from login.jsp. So as soon as the user first the admin logins here, admin needs to log in here with username and password, with username as admin and password is given here. So with username and password, once the admin logins, he enters into home.jsp. Then inside the home.jsp, uh, the file is included here, sidebar.jsp. So inside the sidebar.jsp, we are having the menu here. Menu is home, user, vehicle. We are having the menu home, user, vehicle, and insurance. So whichever you want, you can use the menu here. Once you click on the user, the control goes to the user form. So once you click on the user, control goes to the user form. Inside the user form, the user details are given here. You can add the user. Home users list is given here. You can add the user, and user details are given. So there is a form given here. Once you submit these user details like username, password, gender, and nationality and license number, and role and authority. Once you submit, then the control goes to your form action is given as save user data.html. So the control goes to the controller now. So where is the controller here? Controller goes to user controller. User controller.java, where this is the URL for user form. The control comes from user form to user controller, and public model and view show user form. And excuse me. Once you click on the add user, then the control goes to this control comes here, save user data. So here public model and you save user model attribute user model user model and view MAB equal to new model and view of application constants dot master underscore page. If user dot get id equal to null and if user DAO dot save user, then first it goes to the save method of user DAO. It goes to the from the controller. The control goes to save method of user DAO. Inside the save method of user DAO, this is the interface, and there is an implementation class here. Inside the save method of user DAO, boolean flag is false, and here some string encoded is equal to new this bcrypt password encoder dot encode user dot get password and user dot set password of encoded. Session factory dot get current session dot save or update of user flag is assigned to true. Then next, the control return backs here. And the control returns to user DAO, and the here the model is saved here. And next, so that you can add the user like that, and similarly, you can add the insurance form is there. Like that, similarly, insurance form is there, where you can add the insurance here, where you can add the insurance details like serial number, insurance provider, insurance number, insurance valid date, insurance holder, and the actions. So you can add, as well as there is an insurance form here. And if you submit this insurance form, these are the fields you need to submit inside the insurance form. It is provider, insurance number, insurance valid date, and then when you submit, then the control goes to save insurance data.html. So similarly, you have a vehicle form also, where you can add the vehicle details. So for vehicle details, what are the fields you need to submit here? You need to submit the vehicle username, source, category, plate number, manufacturer, type, etc. So you need to submit these vehicle details and then say submit. Like that, so you can add the user, you can edit the user, you can delete the user. Similarly, you can add the vehicle form, and you can edit and you can also delete the vehicle numbers. And similarly, you can add the insurance details and you can edit the insurance details, and similarly you can delete the details. So now I'll run this project and show you. Right click on the project. Once you right click on the project, say run as. say run as run on server. Then select the Tomcat server, say next, select the appropriate project and say finish. Now the server is starting. So the server is starting. Yeah, since you need to first log in. As the control enters into login, so you need to log with this. This is the username and admin. There is a password here. When you say submit, the control goes to home.jsp. So this is the home.jsp where this is the toggle bar where you are having the menu here. Inside the user, you are having add user and view users, and this is the vehicle insurance search and change password. So once I set add user, then you can add the user here, give some username here, Scott, gender is male, nationality, and some license number, and role is user. Then you say save. Once you say save, you can see the users list here. Yeah, Scott is also entered in the users list. So now you can edit this. First you can take the insurance details. You can add the insurance details here. Insurance provider, insurance number, and insurance valid date. And then say save. Once you save that, and you can see the insurance list also. This is added here. Now you can edit this insurance details also. You can edit any field, and you can check whether it is updated or not. The insurance provider is updated. Then next you can go for vehicle. Similarly, you can see the vehicle list. You can add the vehicle list. You can go here and go for the user, view users. Inside view users, you can add the vehicle details also. Your source, category car, plate number, manufacturer, color, can give the details here. Registration date, pending fines, and then say save. Then you can see the vehicles list here. And if you want, you can delete the vehicle list. So this is about the vehicle insurance system. So hope you understood. So I'll continue in the next video. Thank you.